Okay. Good morning. How are you people? ठीक है सर. क्या है? ठीक है. ठीक है का भी बहुत सारा तरीका होता है ना. ऐसा भी ठीक होता है, ऐसा भी ठीक होता है. कुछ लोग बहुत टाइप का वेव्स है ठीक होने का. ओके, चलो गुड है. सो व्हाट डू वी डू नाउ? What have we done in the last class? क्या समझे थे? There was the discussion on the topic of weather and climate, and heat budget is one thing that we started with, right? And did we understand how the heat budget? What is heat budget? What was heat budget? क्या समझे? Help me. Help me. Huh? Just help me the sequence. क्या समझे हम? Because what would be the sequence that we'll try to follow in the class? You people have understood something? तो थोड़ा सा share कर लो मुझसे भी. First we'll talk of composition, है ना? वो देखो sequence है आपका copy में. So composition of the atmosphere followed by structure of the atmosphere. When we are talking of the structure of the atmosphere, then we'll also talk after the structure the heat in the atmosphere, है ना? So what are the ways in which the atmosphere gets heated, ways of heating. Then heat budget, how much heat comes in, how much heat goes out. And we also know finally that the total heat budget of the earth is balanced budget, है ना? Which means whatever amount of heat we are getting, ultimately we are giving up all the heat back to the मतलब atmosphere is also giving it back to the space. ठीक है? It's not going to the atmosphere. From the atmosphere it has to go to space. Okay. So from the atmosphere it goes to the space. Clear है? Okay. Then what happens? So this was vertical heat budget. Then horizontally we understood that the heat in tropical regions is received more and released less, and in polar subpolar region it is received less and released more, which means one region is spending more, the other region is collecting more. ठीक है? And hence there must be some heat transfer happening from the surplus collection to the surplus expenditure region or release region. ठीक है? So that heat transfer takes place in the atmosphere also. ठीक है? And while it is taking place in the atmosphere, it takes different phenomenon. It turns into different phenomena, right? Such as evaporation is one way, so that's how clouds will be formed. Winds is another way, and we saw many things. So there are many phenomena which take place in the atmosphere, and all those phenomena are what we call as the weather phenomena. उन सबको हम क्या बोलते हैं? Weather phenomena. And weather phenomena are over short period of time, and when the same thing collectively you consider for a region for long period of time, है ना? So then it turns into climate. So weather and climate, and this way we understand that in different regions of the earth there will be different types of weather and climate. So different regions will have different weather and climate. Okay, this is how we come to know of the world weather and climate, right? And once we are done with this much, along with the vegetation, that's it. This is the climate thing. ठीक है? So this much we need to do in climate. Is that okay? ठीक है. So where should we start from? ये sequence में. From the composition of the atmosphere. ठीक है? So this is the sequence that we will follow. Now let us start with the topic. So you can maybe put the subheading as composition of the atmosphere. Right? So, good. So when you talk of the composition, now just before that composition thing, first of all, Is the Earth the only planet to have a atmosphere? I did ask you last time also, and you told me no. So which other planets have atmosphere, and what is their atmosphere mainly made up of? ठीक है, तो किस किस का atmosphere है? Sun obviously वो तो खुद ही मतलब it doesn't have an atmosphere around itself. There is no layer of gas around sun. Okay. Same ways for Mercury also we don't have a atmosphere. Why? Because Mercury is also very hot, close to the sun, so it's not able to hold the gases. ठीक है. So Mercury does not have. But when you go beyond, so when you come to Venus, Venus has an atmosphere made up of carbon dioxide. Earth has a atmosphere made up of nitrogen 78%, 21%. So total 99% हमारा atmosphere तो oxygen nitrogen है. ठीक है. And third, a Mars having carbon dioxide, then Jupiter, hydrogen and helium, which means the outermost gaseous layer of outermost layer of Jupiter through which we can see is made up of hydrogen and helium. Even the remaining part of Jupiter is made up of gases only, but there it has a opaque nature. That's why we see the planet. So what you see as Jupiter are the opaque gases. What you don't see is the top layer, which is the transparent gas of Jupiter. That's the atmosphere of Jupiter. Okay? Then Saturn, hydrogen, helium, Uranus, Neptune, all of these. Right? So these are the different planets having their different atmosphere. Is that okay? So सभी planets का कुछ ना कुछ atmosphere है except for Mercury. Right? Then once you come to the atmosphere of the Earth, so now let us come to atmosphere of the Earth. Right? So when we talk of the atmosphere of the Earth, the the composition is this. Right? Which I would like you to write down also. Maybe कहीं पे लिख लो अपना copy में. The composition of Earth's atmosphere. Okay. Right. So लिख लीजिए if you feel like, because they can ask you this question: which gases are there in the atmosphere except for nitrogen and oxygen? तो एक्सेप्ट फॉर नाइट्रोजन ऑक्सीजन कौन सा है आपको पता होना चाहिए, और कितना उनका क्या सीक्वेंस है इन टर्म्स ऑफ देयर प्रोपोर्शन और क्वांटिटी. Okay, right. So what are these? These are all the gases in the atmosphere. Gases. Okay. But in the atmosphere, do we have only, is the atmosphere made up of only gases, or are there something more? There is dust particles as well as water vapor. ठीक है, तो वो दो चीजें भी हैं. So in addition to the gases, the atmosphere also has water vapor as well as dust particles, right? So it is also having these two. Okay, water vapor and dust particle. So when we talk of the water vapor in the atmosphere, so how much water vapor is there? Ranging from 1% to 4% of the total volume of the atmospheric composition. Okay, ranging from 1% to 4%. So some of the driest regions will have nearly 1% of the total atmospheric composition, and some of the wettest regions will have nearly 4% of the total atmospheric composition. Okay, so 1% to 4% is there. And what are the processes by which water vapor is added? Evaporation, transpiration, sublimation. Very good. और कुछ है? Evaporation, transpiration, sublimation. क्या होता है ये सब? Evaporation, you know, volcanic activity. Very good, right? Because volcanoes were the source, right? So these are the sources from which water vapor come into the atmosphere. So evaporation मतलब liquid to gas. ठीक है, very good. And then second, transpiration मतलब plants to into the atmosphere. Transpiration होता है ना, वो कहाँ से होता है? लीव्स का नीचे का सरफेस है. ठीक है, लीफ के नीचे होता है ना, स्टोमाटा टाइप का कुछ. ऊपर होता है, नीचे होता है, दोनों तरफ होता है. राइट, ठीक है. सो इट्स द फ्रॉम द स्टोमाटा part of the leaves that we get transpiration is the water lost by the plant to the atmosphere. Simple, right? If you want to understand and write, that is the process. It is the water lost by plant to the atmosphere. ठीक है. Then what is the next thing? Sublimation मतलब solid to, जैसे कि कहाँ होगा? Where? हाँ, स्नो टू, स्नो और ग्लेशियर्स कहाँ पे सीधा इवेपोरेट होकर के? In the glacial region, snow covered region, you find this phenomena. Over the oceans you get evaporation, over this region you get. Is that okay? ठीक है, very good. So then what else? So this is the process, and then the volcanic activity. Volcanic activity was earlier adding too much, but now gradually its role has declined pretty much because we don't have many volcanoes. Is that okay? So now volcanic activity is adding very less water vapor to the atmosphere. Is that okay? Okay. So that's how it is added, right? And how much water vapor do you find in different regions of the atmosphere? Huh? कहाँ पे? Where do you find more water vapor? Where do you find less water vapor? There is some pattern. Come again. At equator it is higher, the water vapor, and in the polar region it is lower. Why? क्यों लगता है ऐसा? क्यों होगा? The temperature is higher in the, but tropic में सबसे ज़्यादा temperature होता है equator. Water, ocean is more, और ocean is more तो अगर मान लो tropic में ocean ज़्यादा है तो वहाँ पे ज़्यादा होगा. There is another region which you don't know. Okay, जो नहीं है अभी आपको नहीं पता है. That is called as the pressure. The equatorial region has lower pressure. Tropical region has higher pressure. Higher pressure means wind is coming down. Lower pressure means wind is going up. So where the wind is going up, that is the region where more evaporation will take place. ठीक है, and hence more water addition will be there. मान लो प्यास लगी है, पानी है ही नहीं. ठीक है, so tropical region is like that. It is hot, but there is less chance of rising air. Why? Because there is a high pressure there. Why is the high pressure? We'll talk. ठीक है, but so what do we write? लिखना है यहाँ पे, तो point लिखना है. So what is the pattern of moisture availability? लिखना है ना. So write down the pattern of moisture availability. Pattern of moisture availability. ठीक है, so when you talk of the pattern of moisture availability, it decreases with altitude in general. Decreases with altitude in general. Decreases with altitude in general. Hence equatorial region has maximum, and polar region has relatively less. Polar region has relatively less. ठीक है, डिड आई से ऑल्टीट्यूड, है ना, तो ऑल्टीट्यूड क्या हुआ, ये ऑल्टीट्यूड तो नहीं हुआ, ये तो लैटिट्यूड हुआ, है ना, तो ये इसको ऑल्टीट्यूड वर्ड को कैंसिल करके लैटिट्यूड लिख लो। ऑल्टीट्यूड तो हाइट हुआ ना, ठीक है, तो हमने तो पोलर इक्वेटोरियल पोलर लिखा है, ये हाइट तो है नहीं, राइट, सो दिस इज फॉर द लैटिट्यूड, ओके, देन राइट द ऑल्टीट्यूड पॉइंट ऑल्सो। Moisture also decreases with altitude, so it decreases with latitude, ऊपर वाला point, and now it also decreases with altitude. It also decreases with altitude, which means the higher you go, lesser will be the total moisture, right? Lesser will be the total moisture present. So it decreases with altitude also, which means higher we go, lesser total moisture. ठीक है? What do we mean by total moisture? Total moisture means total amount of moisture present in the air. ठीक है? Present in the air. Now why does this happen? This happens because the temperature, the air at different temperature has different capacity for holding moisture. ठीक है? What does that mean? If the air is colder, less evaporation can happen and less moisture it can hold. If the air is hot, more evaporation can happen and the air can also hold more. ठीक है, so as you go higher, what happens to temperature? The temperature decreases. You must have felt when you go from the plain level of the ocean, if you go higher in the aeroplane or in the mountains, what happens? The temperature decreases. As the temperature decreases, the capacity of the air to hold moisture also decreases and hence the total moisture held also decreases. ठीक है, so with altitude total moisture held decreases. Is that okay? Right, why does that happen? Because of temperature. Because temperature is decreasing, so total moisture also decreases. ठीक है, all right, you want to write this? लिख लो. With altitude total moisture decreases because temperature also decreases. With altitude total moisture decreases because temperature also decreases. Total moisture decreases because temperature also decreases. Therefore, capacity to hold moisture. Therefore, capacity to hold moisture also decreases. Okay, good. Now what is the role of water vapor? What does water vapor do in the atmosphere? क्या करता है वो? One, it contains heat. Very good. जैसा greenhouse effect है उसका, right? So it has a greenhouse effect of absorbing heat. So लिखते जाओ साथ-साथ point, right? That it plays a role in absorbing heat. It, yeah. Come again. जब, what did I say about that capacity wala point? That's what you're asking. Yeah. I said when the air will become warmer, it can cause more evaporation and the capacity of the air to hold the evaporated water vapor is also high. Warmer air can hold more, so that is the capacity, that is high. So higher temperature means higher capacity to hold moisture. Is that okay? Increases और डियर आपका आवाज बहुत धीरे आ रहा है मुझे, मतलब ऐसा नहीं, ये फोन नहीं है, हम दोनों सामने ही हैं, तो थोड़ा वॉल्यूम इंक्रीज कर दो. आपने लिखा है डिक्रीजेस, एक डिक्रीज ये लिखा है कि एज द ऑल्टीट्यूड इंक्रीजेस द हाइट डिक्रीजेस, हाँ सॉरी हाइट इंक्रीजेस, टेम्परेचर डिक्रीजेस, देयरफॉर कैपेसिटी ऑल्सो डिक्रीजेस. ठीक है, अभी ठीक है, यही पॉइंट था. ओके, so talking of this insulation thing, because of its greenhouse effect it goes on to absorb heat. Is that okay? So absorption होता है. So that is one major role that the water vapor has. One, which is absorbing the heat in the atmosphere. Does it have any other role? वो तो absorbing heat से हो गया ना. Maintaining Earth's temperature. Yes. Stability of atmosphere कैसा? What do you mean by stability of atmosphere? एक एक करके आप बोलो, आते हैं आपके पास. Yes. Due to? हाँ. Will happen. Due to water vapor, precipitation and rain will happen. That means the atmosphere is stable or not stable if the rain is happening. क्योंकि आपने एक word use किया stability. So when you say a word, maybe others will think, sir, what is the meaning of the word stability of atmosphere? So stability of atmosphere में then you are saying that, sir, it can lead to precipitation or rainfall. So is that stable or not stable when it is raining? अच्छा, गुड और बैड वेदर पहले हम समझते हैं. व्हाट इज गुड वेदर? गुड वेदर कंडीशन किसको बोलते हैं? आपका वाला गुड वेदर नहीं सर, बहुत ही बादल बादल छाया है, बहुत अच्छा लग रहा है ना, फीलिंग वेरी गुड, वो गुड वेदर नहीं है. ठीक है, गुड वेदर क्या है? व्हेन इट इज अ सनी डे, विंड इज स्टेबल, देयर आर नो क्लाउड्स इन द स्काई एंड एवरीथिंग इज क्लियर. दैट यू कॉल एज अ गुड वेदर कंडीशन. ठीक है. एंड व्हाट इज अ बैड वेदर कंडीशन? व्हेन यू हैव लॉट ऑफ क्लाउड्स in the sky and the winds are there and maybe it is about to rain or it is drizzling or whatever, that is bad weather condition. ठीक है. So if the wind is strong and the rain is there and the cloud is there, you call it as a bad weather. And if there is no wind or less wind, no rain and no cloud, you call it as a good weather condition. ठीक है. So this is good and bad. What is stable weather condition? Stable weather किसको बोलेंगे? Again when you don't have too much of air movement, that is good weather. So a good weather condition is a stable condition broadly. ठीक है. Whereas a bad weather condition, ठीक है. So when you say moisture in the air, does it make it a stable condition or not stable condition? Stable हुआ या non stable? If there is lot of moisture in the air and cloud and rain and precipitation, non stable. ठीक है. आपने बात सही बोला था कि sir it affects the stability, but किस side affect करता है ये समझाना पड़ेगा, positively या negatively. ठीक है. Is that okay? Good. So it affects the stability, it affects the heat absorbed. What else? कुछ और भी करता है. Heat transfer हो गया. Heat से related नहीं है ये. Heat वाला part complete. Heat temperature done. Stability वगैरह done. There's another role. Yes. Cloud formation and hence क्लाउड फॉर्मेशन एंड हेंस प्रेसिपिटेशन एंड हेंस एक और चीज करता है वो क्लाउड फॉर्मेशन से, अफेक्ट्स द इंसोलेशन, है ना. सो अफेक्ट्स द इंसोलेशन, बट देयर इज वन मोर वे इट अफेक्ट्स द इंसोलेशन. इट रिफ्रैक्ट्स द लाइट. वाटर वेपर इन द एयर रिफ्रैक्ट्स द लाइट एंड हेंस चेंजेस द कलर ऑफ द स्काई. जैसा रेनबो फॉर्मेशन है वो कैसा होता है? Because of that water vapor present into the atmosphere in a given pattern. So when it is in a given pattern, you get the refracted light going at different angles and you see that rainbow. ठीक है. Or the sky color is affected by this because water droplets the light enters and then gets refracted at different angles because of this. Is that okay? So it does all this. ठीक है. One, temperature. Second, as you said, temperature, precipitation, stability, cloud, and it also refracts the light. ठीक है. Dust particle and water vapor both have this role. Both of them go on to refract light. ठीक है. Then let us come to the next thing. So water vapor का role हमें समझ में आ गया broadly. ठीक है. Then next, dust particle. Dust particles. So we are doing the composition only. So the dust particles. Where do the dust particles come from? Source of dust particles in the atmosphere. One is volcanic eruption. Very good. Sea salt. Sea salt. How does the sea salt go, by the way? Who said? कोई बात नहीं, बिना घबराए बोलना यार. Yes. Sea salt. Very good. So evaporation, when the water droplets are risen in the wave and then the water droplet in the air evaporates, sea salt remains. and this happens over 70% of the earth. Why? Because 70% of the earth is oceanic. ठीक है? So first one we have to write, or sources लिखना है. What are the sources of dust particle? One, volcanism. Second, evaporation over the ocean, right? Over the ocean, what evaporation over the ocean. Then third, as you said, आपने बताया fossil fuel, आपने बोला unburnt carbon, तो burnt particles. उससे भी पहले कुछ और सोचो. सबसे पहले तो dust particle blow होगा ना जमीन से, land, winds. So wind will be causing, है ना? So wind will be a major source. जैसा कि surface के ऊपर evaporation हुआ, ocean पे we had evaporation, on the land you will have winds causing, and then exhaust. The word is exhaust will include, as you said, oil, है ना, fossil fuel या burnt particle, वो सब exhaust है. वो different types of exhaust है. Transport exhaust, industrial exhaust, residential exhaust, है ना? Your chimneys at the house, वो आपका residential exhaust release कर रहा है. कार का exhaust, transport exhaust release कर रहा है. Industrial exhaust, वो बाकी burn particle release कर रहा है या unburned particle release कर रहा है. ठीक है? So exhaust. So one, wind. Second, so what will wind take up? Wind will generally take up the smaller dust particles on the ground. वो किस टाइप का dust particle उठाएगा आपको लगता है? Clay, है ना? Clay, sand, silt, all that. और clay, sand, silt, उसके सिवाय pollens. Vegetation से भी तो ले जाएगा ना? Pollens you must have heard of, है ना? So pollen को कौन ले जाता है एयर में? वो भी तो dust particle है. So that will go from winds only. So wind will drive it. So from the living and the non-living, right? So sand, etc., and pollens. So they are taken by wind. And then exhaust is where you can say in some ways human role comes in. So the anthropogenic dust particles, human-genic or anthropogenic dust particles will come from exhausts. And that will include different exhaust, industrial, residential and transport. ठीक है? अब उसी के अंदर different particles है, burnt particles और unburnt particles. वो सब उसका part है. ठीक है? तो burnt particle को हम क्या बोलते हैं? What do we call burnt particles? Ash. And what do we call the unburnt particle? Soot. Unburnt particle का नाम का word है soot. Soot is unburnt. ठीक है? So soot and ash, right? So soot, ash, pollen, dust, salt, all of this is dust particles, and the source for all of this is land or the surface. So where should we find most of the dust particle? In the atmosphere. In the upper atmosphere or lower atmosphere? Lower atmosphere. Most of the dust particle is found only in the lower. The farther you go from the land or the earth surface, the lesser dust particles. ठीक है? So most of the dust particle is closer to the land. Alright? ये सब लिखना है क्योंकि यही आपका climate बनाएगा. Because these are the things that I will ask you. At some stage I'll ask you, where should I find most of the dust particle? आपको पता होना चाहिए कि sir it should be closer to the land. Then I will ask you which are the different types of dust particle. तो ये इसीलिए यहाँ पे लिखवा रहे हैं. Because that will help you create the climate later on. Okay? Now, is there any other source of dust particle apart from this? और कुछ है? Very good. So space. The dust coming from space. तो space से भी dust आता है. But वो बहुत छोटा amount है. That's a very small amount. Right? So we can write a small amount of dust comes from space also. ठीक है? Small amount of dust comes from space also. All right. So good enough. So you understand the sources of dust particles. Sources समझ में आ गया. Now, what is the role that they play in the atmosphere? Role of dust particle. Very good. हाँ जी. Condensation कैसा करेगा? Around the dust particle. So One is they help in condensation. Okay, so dust particle play a role in condensation, right? But not all dust particle play a role in condensation. One group of dust particle play a role in condensation. So therefore you have to understand groups of dust particle. Any dust particle can have two behaviors. Either it can attract water or it can repel water. ठीक है? So ये मैं लिखवाऊंगा, पहला भी समझ लो. Any dust particle can either attract को हम क्या बोलते हैं? Scope, scopic. किसी भी चीज को जब आप अट्रैक्ट करते हैं या उसका पास जाते हैं, यू कॉल इट एज स्कोप. जैसा कि आपका टेलीस्कोप, माइक्रोस्कोप, इसका मतलब क्या है? इट विल टेक यू क्लोजर. ठीक है. और जब आप दूर करते हो, फोबिया और फोबिक. ठीक है. सो डस्ट पार्टिकल्स आर ऑल्सो ऑफ टू टाइप्स, वाटर अट्रैक्टिंग एंड वाटर रिपेलिंग. तो वाटर अट्रैक्टिंग को क्या बोलेंगे? हाइड्रोस्कोपिक. और वाटर रिपेलिंग को हाइड्रो और हाइग्रो. वी यूज द वर्ड हाइग्रो, नॉट ड्रो, राइट? हाइग्रोफोबिक. So there are two types of particles, hygrophobic and hygro. So which one will play a role in condensation? Hygroscopic particles. ठीक है. So we have to write this. ये लिखना है हमें. That dust particles play a role in condensation. These are hygroscopic dust particles. Hygroscopic dust particles play a role in condensation. These are hygroscopic dust particles. And second, they also play a role in scattering of light. Scattering of light. Second, play a role in scattering of light. Third, in atmospheric visibility. They play a role in atmospheric visibility. If there are more dust particles in the atmosphere, visibility will be less. Simple logic. ठीक है. So play a role in atmospheric visibility also. Okay. And in which region should we find more dust particle and which region should we find less dust particle? Where there is more precipitation and rain. What does the rain do to the dust particle? Does it allow it to stay in the air or does it wash it down? So in rainy regions, dust particle will be less. So regions which get frequent rain, the dust particle is less. Whereas regions which are relatively dry, such as deserts and all, there will be relatively higher dust particle in the air. Okay? So drier areas would generally have higher dust particle and rainier areas would have generally lesser dust particles because the dust particle gets washed down. Okay? So please do write that also. That rainy areas, lesser dust particles, whereas drier areas, higher dust particles. Okay, good enough. So now let us come to the next part. Now we come to the structure. So composition done, then structure of the atmosphere. Structure of atmosphere. So when we talk of the structure of the atmosphere, we are first we'll talk vertical. Vertical structure means from the surface to up. Okay. So vertical structure, as per our NCERT, we'll follow the vertically the atmosphere goes up to 3,500 kilometers. Okay. Vertically, please do write. Vertically the atmosphere goes up to 3,500 kilometer from the earth's surface. So we find gases we find gases almost up to this height. We find gases almost up to this height. Okay, so technically the atmosphere is up to this height. But most of the gases, technically we find gases up to this height, but most of the gases are found, within bracket 99%. 99% of the gases are found in the lower 32 kilometers. Are found in the lower 32 kilometers. ठीक है? So बाकी कितना बच गया? 3468 kilometers में there is only 1% of the gases. This is the density of the atmosphere. This is how the atmosphere's density changes. ठीक है? So if I have to show you a diagram, it would look something like this. ऐसा देखो. Can you see in that diagram? Most of the gases are in the lower region. As you go higher and higher, the gases become much less. Okay, and in the top one, you will find only 1% of the gases. Okay. Therefore, for our practical purpose, right, which region do we call space? वैसे तो हमको space कहाँ से बोलना चाहिए? 3500. But which region do we start calling as space? For example, you must have heard we have put our satellites, है ना? तो सैटेलाइट हम 3500 के ऊपर डालते हैं. हाँ, आपने सुना होगा इंटरनेशनल स्पेस स्टेशन है. तो कहाँ पे है वो सब एटमॉस्फेयर में है. ठीक है, बट वी स्टिल कॉल दैट रीजन एज स्पेस. व्हाई? बिकॉज वन, द गैस प्रेजेंस इज वेरी लेस, right, and the effects of gravity and all also go on decreasing. So that level where that region we call as, so for our practical purpose we have defined space as region 100 kilometer above the ground level. Okay, so the region which is 100 kilometer and above the ground level, we start calling that as space, and anyone and anything that goes up to that height, we say it has gone in space. Okay, so that level is called as Kármán line, K-A-R-M-A-N line. ठीक है, तो वो भी लिख लो, right, that the region which goes, the region which is above 100 kilometer, above 100 kilometer from mean sea level, region which is above 100 kilometer from mean sea level is known as space, is known as space in our general discussion. General discussion. And objects put above this height are said to be in space, like satellites, etc. ठीक है, objects put above this region are known to be in space, such as satellites. Okay, the line separating the space from the lower 100 kilometer, the line separating the space from the lower 100 kilometer is known as the Kármán line, K-A-R-M-A-N, Kármán line. Okay, so always remember, whenever they say कि space में गया, तो don't think कि अच्छा 3500 किलोमीटर चला गया. Once you place it somewhere around 100 kilometer and above, it is in space. ठीक है? Okay, अच्छा एक और चीज बताओ. How do things, for example, when we put a satellite in the space or an international space station in the space, ठीक है, how does it keep going around the earth?
Sir, it is under the
Effect of gravity. Okay, so under the effect of gravity, what is happening to it? Is it because of the rotation that there is a centrifugal force and there is a centripetal force, and because of that it keeps going? क्या हो रहा है? If I say a simple line, all the space stations and the satellites are falling freely on the earth, always. Is this right or wrong? All the space stations, everything that is going around the earth put by us in their orbits, they are, in terms of physics, they are freely falling on the earth. Is this right or wrong? And if I say this is right, right है wrong है? Everything is falling on earth. Is this right or wrong? There is a lot of space dust that you have and everything is still falling. How is it right?
Sir, if it is right,
Huh.
then because of the centripetal
Huh.
stays there and it does not come.
So it is falling and it is because of the centripetal force and then it stays. अच्छा एक और चीज बताओ. Let me ask you this way. Let us say that you are moving in a lift and just don't imagine what will happen when you land. Let us say the lift's rope gets broken. ठीक है? Then with respect to the lift, are you falling? Will you ever touch the floor of the lift if you are in air? Will you ever touch the floor of the lift if you were in air when the rope got broken? Let us say आप कूदे, लिफ्ट में खड़ा था, आप कूदे, जैसे ही आप कूद के थोड़ा हवा में गए, लिफ्ट का रोप भी कट गया. Now the lift is falling, so are you. ठीक है? So both of them are freely falling. But let us say you are on the 1000th floor of some building, imaginable. ठीक है? So for the next 5-7 minutes or 2-3 minutes, will you ever touch the floor of the lift? Why? Because both of them are falling. है ना? And in that case, to ensure that the object remains suspended in air in the lift, will you have to spend any energy? No, that is the natural phenomena now. तो आपको energy spend नहीं करना पड़ेगा. So if you want to suspend something in a lift without spending any energy, is this not the best possible way? Ensure that the lift keeps falling and the object also keeps falling, so it will remain suspended and no energy required. कोई magnetism कुछ नहीं लगाना. We use the same characteristic of the earth. Why? Because the earth is revolving, not rotating. है ना? Earth is running actually. ठीक है? And earth has a gravity. So the earth's gravity ensures that all those satellites which are there, they keep falling on the earth. But by the time they fall or they would touch the earth itself has moved. So they are perpetually falling on earth. But they will never touch the earth. It's that lift situation. That's why we don't have to have an external source of energy for those satellites, because they are using earth's gravity to fall on it. ठीक है? बट वो अर्थ को कैच कभी नहीं कर पाते. ठीक है? बिकॉज अर्थ इज ऑल्सो, ठीक है? तो आप भाग रहे हो और एक चिड़िया आपका पीछे उड़ी है और वो आपके कंधे पे बैठना चाहती है. जितना तेज आप भाग रहे हो उतना तेज चिड़िया भाग रही है. तो चिड़िया आपके पीछे पीछे भागती रहेगी लेकिन वो आपको कभी पकड़ नहीं पाएगी. ठीक है? द ओनली वे टू escape a bullet is either run faster than it or get in a side. Depends आप सुपरमैन हो या क्या हो. ठीक है? Right? So do we understand? So once you place those objects at that height, that's how we figure out the position of those satellites or objects. कि कहाँ पे इसको place करेंगे? So it will be best place and continue to move forever. That's how you fix that orbit. ठीक है? Depending on different objects. Okay? So those things are perpetually falling on earth. But it's only that the earth is also perpetually running. जिस दिन earth रुक जाएगा, सब कुछ वापस आ जाएगा. ठीक है? Okay. So should we move beyond? Right? So do you understand this simple concept of space? तो हम कहां पे स्पेस बोलना शुरू करते हैं? और इसीलिए हम बहुत बार अर्थ का कैरेक्टरिस्टिक यूज करके कोई एक्सटर्नल एनर्जी सोर्स के बिना भी चीजों को मूव करा पाते हैं. ठीक है? और होल्ड देम इन स्पेस. सारा डस्ट पार्टिकल तो वैसे ही है ना, उसमें कोई एनर्जी सोर्स तो है नहीं, बट वो फिर भी अर्थ के चारों ओर घूम रहा है. ठीक है, ओके. सो गुड, लेट अस गो बियॉन्ड दिस. सो वाटर वेपर वी अंडरस्टैंड, डस्ट पार्टिकल वी अंडरस्टैंड, स्पेस वी अंडरस्टैंड. स्पेस तक समझ में आ गया, सिंपल स्पेस. ठीक है. देन लेट अस गो टू द नेक्स्ट थिंग. सो व्हेन यू टॉक ऑफ द स्ट्रक्चर फर्दर, दिस पार्ट यहां पे, राइट, वी टॉक ऑफ द vertical structure of the atmosphere in two terms. One in terms of the chemical composition. Please do write this. Chemical composition, structure of the atmosphere on the basis of chemical composition as well as on the basis of temperature. As well as on the basis of temperature. So on these two bases, we go on to talk of the vertical structure of the atmosphere. ठीक है. So chemical composition and temperature. So when you talk of the chemical composition of the atmosphere, on that basis, when you see this 3,500 kilometer layer, there are again two parts to it. One is the lower 88 kilometer and the remaining 3,500 kilometers. So in terms of chemical composition, there are two parts vertically of the atmosphere. The lower part 88 kilometer, the upper part remaining 3,500. Okay. So what is the chemical composition of these two? The one which is lower is called as homosphere. Homosphere of the earth. ठीक है, ये नीचे वाले को हम क्या बोलते हैं? Homosphere. Why? Because this has a homogeneous mix of gases. The mix of gases in this region is homogeneous, which means anywhere in this region, nitrogen will always be 78%, oxygen will always be 21%, and so on. Of the total gas present, right? If you take a bottle of gas in this region anywhere, in that, whatever the total amount, but always 78% will be nitrogen and 21% will be oxygen and carbon dioxide less than 1% and so on. ठीक है, is that okay? तो अगर आप माउंट एवरेस्ट का टॉप पे भी जाकर के एक बॉटल एयर फिल करके ले आओ, ठीक है, you go there, you open a bottle, you close that bottle and bring it down, and then you test that in that air, obviously the total amount of air in the bottle will be less than what you will get on the ground. But in that air, always 78% will be oxygen, sorry, nitrogen, and 21% will be oxygen and so on. Do we get it? But if you do the same exercise in the upper region, when you go beyond this 88, this region is called as heterosphere. Heterosphere. Hetero का मतलब क्या होता है? Something which is different. So this is a region where the chemical composition is different. ठीक है? So in the heterosphere, everywhere the chemical composition is different. How? The lower regions have denser gases, and the upper regions have lighter gases. Which are the lighter gases? एक दो example बोलो. Hydrogen, helium. So when you go to all these regions, ऊपर वाला part, when you go to let's say 3,200 kilometer from the surface, you will not find nitrogen and oxygen there. You will only find hydrogen, helium, etc. Whereas when you come to let us say 200 kilometer above the ground, so in that region you will mostly find nitrogen and oxygen. There you will not find hydrogen and helium. Okay, so this is what you call as heterogeneous atmosphere. Is that okay? आ गया समझ में? ठीक है. So on the basis of chemical composition, this is the layer, homogeneous and heterogeneous. Clear है? हाँ? पक्का? कोई डाउट है? पक्का? ठीक है. साइंस है? थोड़ा है ना, डाउट है? नहीं सर, समझ में आ गया? यस सर. साइंस है? मिक्स थोड़ा है सर. ठीक है, चलेगा इतना तो. ऑलराइट. यस या. Is it correct that these gases are organized in spherical sphere around the earth? स्फेरिकल शेल्स अराउंड द अर्थ। तो आपके कहने का मतलब एक लेयर होमोजेनस, उसका ऊपर एक लेयर नाइट्रोजन, हाँ वही मैं कह रहा हूँ, एक लेयर नाइट्रोजन, उसका ऊपर एक लेयर ऑक्सीजन, उसका ऊपर एक लेयर, एंड देन सबसे ऊपर हाइड्रोजन। यस, so you'll find it in some kind of spherical shape when you see the whole earth. That's pretty logical from this ना। ठीक है, तो इसी के अंदर अगर मैं लाइंस बनाता जाऊंगा ऐसा, मान लो यहाँ पे एक ऐसा लाइन है, ठीक है, तो ये एक गैस का होगा, उसका ऊपर कोई दूसरा लाइन है ये वाला रीजन, तो ये दूसरा गैस का होगा। सो इफ यू टेक द होल शेप यू विल गेट अ स्फेरिकल शेप। ठीक है, इट शुड, राइट, बिकॉज दिस लॉजिक सेज दिस ओनली, right? So now, and I'm saying this out of logical conclusion. So logically I'm concluding, I've not read, but because you asked, so I just thought क्या होना चाहिए, so ऐसा ही होना चाहिए spherical, क्योंकि layers बना हुआ है, ठीक है, but in the heterosphere as you said. Good. So good enough. Now let us come to the next part. So the next one after this is on the basis of temperature. So should we do the temperature thing? Structure on basis of temperature. Structure on the basis of temperature. ठीक है? So when you talk of this, the structure on the basis of temperature, what do we get? So please see, I'm trying to draw in this diagram starting slightly at the lower end of the paper, यहाँ पे कहीं I'm leaving all that space क्योंकि यही मुझे ड्रॉ करना है, ठीक है। So this is the surface of the earth, surface of earth, and please do draw with me, all of you. The surface of the earth, and let us say this is 0 degree equator and this is 90 degree pole. Okay, 0 degree equator and 90 degree pole region, ऐसा। Clear? So which are the different vertical regions that we have? Let us see. So when you talk of these vertical regions, the first vertical region that you get in this way is this region known as ट्रोपोस्फेयर, सबसे नीचे वाला, ठीक है। The troposphere region. So that is the lowest region of the atmosphere in terms of temperature, troposphere, right? And this line that I have drawn is the region which separates the troposphere from above part. So the troposphere ends with this line, upper line, ठीक है। We call this boundary of the troposphere as tropopause. Tropopause. So the boundary of the troposphere is the tropopause. ठीक है? And what is the height of the tropopause? It is varies with equator. It is 18 kilometer as we are drawing, and at the pole it is 8 kilometers. ठीक है? 8 and 18, simple, ठीक है। So different regions we have different height, okay, and what is the average height in the middle? It is around 13 kilometers. The average height in the middle is 13 kilometers. Middle means mid latitude, ठीक है। So please go on drawing everything, साथ साथ सब कुछ बनाते रहिए। राइट, नाउ व्हाट इज द कैरेक्टरिस्टिक ऑफ दिस रीजन, अब वो भी देखते हैं, पहला इतना बना लिया, ओके। नाउ इफ आई आस्क यू दैट व्हेन यू टॉक ऑफ द सरफेस ऑफ द अर्थ, सो व्हाट टाइप ऑफ टेम्परेचर शुड वी एक्सपेक्ट अराउंड इक्वेटर, वार्म और कोल्ड? वार्म, तो यहां पे हम बना सकते हैं वार्म टेम्परेचर, ऐसा, दिस रीजन विल बी वार्म, ये वाला, एंड व्हाट शुड बी द टेम्परेचर अराउंड पोल? पोल शुड बी cold, so this region will be relatively cold, ठीक है। and do draw along with me. If you want, I can go slow, but keep drawing also. So warm, cold. Is that clear? Now, because the equatorial region is warm, so there the air in contact, because this is the region which is touching the ground, that's the only part of the atmosphere which touches the ground. Right? Every other part of the atmosphere is above it. So if this part is touching the ground, then it should be affected by the ground. Yes or no? Affect bhi hona chahiye. So if it is affected by the ground, then whatever is the temperature of the ground will affect it. So in the equatorial region, what is the temperature of the ground? Warm or cold? अच्छा एक चीज है देखो ज्योग्राफी का क्लास में ना यू माइट से सर मतलब आई डू रीड ऑल्सो यू नो आई हैव रेड दिस फीडबैक फॉर मी ऑन वेरियस प्लेटफॉर्म आप लोग का फीडबैक प्लस ऑनलाइन प्लेटफॉर्म फीडबैक यार ज्योग्राफी के क्लास में ना वो बस क्वेश्चन पूछते रहते हैं पढ़ाते तो कुछ है नहीं ठीक है वो पूरा क्लास में आपसे पूछते रहेंगे एज इफ देयर इज नथिंग टू टीच एंड ओनली आस्क दैट इज माई टीचिंग स्टाइल राइट आई कांट चेंज इट why because this is something that my teachers never did in the subjects which I never understood ठीक है all the subjects that I never understood were the subjects where my teacher never asked me anything because the teacher came to the class and they kept dictating and they kept dictating and they kept dictating and I initially tried and then tried more and then I left ठीक है सो मुझे समझ में आ गया कि यार ये तो काम करने नहीं वाला राइट दैट आई कम एंड आई डिक्टेट एंड यू राइट उसके लिए आपको यहां आने की जरूरत नहीं है ठीक है टेलीग्राम पे यहां वहां बहुत जगह हमारा नोट वीडियो सब मिल रहा है देख लो वहीं से राइट अगर क्लास में खड़े हैं या बैठे हैं तो सिंपल पर्पस है क्या है आंसर देना है ठीक है और आंसर देने के लिए क्या करना पड़ेगा समझना पड़ेगा है ना तो अगर समझ गया तो मेरा पर्पस इज सॉल्व्ड बिकॉज दैट्स व्हाई यू हैव कम टू द क्लास ओके एंड हेंस आई वांट आंसर फ्रॉम एवरीवन सबको आंसर देना है अगर आप लोग डल हो जाओगे तो मुझे लगता है यार इंटरेस्टेड नहीं है या इनको ब्रेक का जरूरत है या आईएएस का तैयारी छोड़ के स्टेट के लिए शुरू हो गए या ज्यादा टाइम ट्विटर पे बिता रहे ठीक है तो आप देखो क्या करना है लाइफ में अगर इधर आए हैं और वन मोर थिंग आई हैव सेड सो मेनी टाइम्स इन द लास्ट फ्यू डेज 1,60,000 70,000 रुपए दे करके कितना दिया 180 देखो और ज्यादा दिया आपने तो सर नहीं 10,000 रुपए कहां छोड़ा विजन ने ठीक है तो अगर 180 लिया है आपसे और उसके बाद भी आप इधर आके सिर्फ गप्पे मारने सोने आए हो यार इतने में तो 4 एसी लग जाते रूम में है ना तो क्यों जबरदस्ती अच्छा सर एसी तो वैसे भी लगा हुआ है हम अमीर वाले लोग हैं सर डोंट कंसिडर अस गरीब है ना कितनों के रूम पे एसी लगा हुआ है ये देखो ये सारे अमीर वाले हैं जिनके रूम में एसी लगा हुआ है ठीक है बाकी तुम तो सारे मेरे जैसे गरीब लोग हो जमीन पे पानी डाल डाल के पड़े हो ठीक है आई रिमेम्बर मेरे रूम में जब गर्मी होता था ठीक है और लाइट भी नहीं होता था तो एक बाल्टी में पानी लाते थे और एक बोतल साइड में रखते थे और साइड बैठ के ना चारों ओर ऐसा पानी गिरा लेते थे और कभी कभी ज्यादा गर्मी होता था तो थोड़ा पानी बेड पे भी डाल देते थे ताकि जब तक वो बेड ठंडा रहेगा तब तक पढ़ सकते हैं क्योंकि ज्यादातर पैसा तो कोचिंग वालों ने ले लिया था हमारा टाइम पे भी वही हिसाब था यार पैसा कम होता था ठीक है लेकिन पढ़ते थे लगता था यार वी हैव स्पेंड मनी सो वी शुड स्टडी हार्ड वर्क नहीं करेंगे और दैट्स द हार्ड वर्क बिकॉज ऑफ विच आई एम सिटिंग हियर आई एम नॉट सिटिंग हियर बिकॉज आई हैव डन ज्योग्राफी इन माय स्कूल कॉलेज नहीं ठीक है तो आईएएस नहीं भी बना तो कम से कम दाल रोटी चला लेता हूं उससे ज्यादा भी कभी कभी पनीर भी खा लेता हूं ठीक है all right okay so all I intend to say कि work hard ठीक है, तो वर्क हार्ड करने के लिए थोड़ा आंसर दो यार, ऐसा डल के जैसा। आप लोग तो अभी 20s में ऐसा बैठे हो जैसे कि रिटायर हो चुके हो और बस पेंशन का वेट कर रहे हो कि कल से पेंशन चालू है उसके बाद अब कुछ करना नहीं है। ठीक है, क्या करना है इस दुनिया में, क्या रखा हुआ है, ऐसा फीलिंग नहीं आना चाहिए। ओके, सो थोड़ा सा पार्टिसिपेट करना है। इतना सारा मैं क्यों कहानी बता रहा हूं, ताकि आप लोग अपना मुंह खोलना शुरू करिए। ठीक है, so when I'm asking, please try to answer. If you do not understand, raise your hand and ask me. That's the purpose of the class, right? Otherwise कुछ purpose solve नहीं होने वाला, right? अगर and I'm seriously honest कि अगर आपको सिर्फ नोट्स ही चाहिए थे और वीडियो ही देखना था, तो वो तो विजन बहुत जगह पे फ्रीली छोड़ रखा है हमने, वो डेलिबरेट है। ठीक है, ताकि आप लोग ले सको, जिसको नहीं आना है वो तो आपको भी दिया हुआ है, घर पे बैठो। आई थिंक सर दे हैव द वीडियो एक्सेस, ऑल ऑफ देम, है ना? तो है तो यार फिर यहाँ बैठने का क्या जरूरत है, क्यों इतने। अच्छा, कपड़े वपड़े भी दिखाने हैं सर, कपड़ा वपड़ा नया खरीदा है, सब कुछ चेक कराना होता है तो आप, मैं सच बता रहा हूँ, आप में से 90% के कपड़े दिन खाने लायक नहीं है ठीक है, ना प्रॉपरली आयरन करते हो, ना साफ करते हो। साथ वाले से पूछो कितना स्टिंग कर रहा है स्टिंग छुपाने के लिए परफ्यूम मारते रहते हो पूरा ठंड परफ्यूम के बल पे निकाल रखा है ना? तो अभी क्या करना है? हाँ सर छोड़ दो, बस आंसर देंगे, वी प्रॉमिस, ऐसा बोलना है क्या? सर बस करो सर, इससे ज्यादा अपने बारे में बुराई नहीं सुना जाता। ठीक है, तो हम आंसर कर देंगे सर। ठीक है, सो शुड आई एक्सपेक्ट? हाँ, तो अभी बोलना शुरू करिए। नहीं, मैंने क्वेश्चन ही नहीं पूछा है ये थोड़ी बस ऐसे ही बस यस सर चिल्लाए जा रहे, क्वेश्चन तो पूछने दो यार। ओके, गुड। सो नाउ वी आर एक्टिव अगेन। ठीक है, कभी कभी होता है क्लास डल हो जाती है तो थोड़ा एक्टिव करना पड़ता है आप लोग को, यू नो, नहीं तो सोए होते हैं। जब क्लास में साथ वाला हंस रहा होता है ना, तो सब उठ जाए, अरे क्या हुआ, कुछ तो काम का हुआ है मतलब उतनी देर से मैं बोल रहा हूँ कुछ काम का नहीं हो रहा, साथ वाला हंसा जरूर कुछ काम का हुआ है ये क्या एटीट्यूड है यार स्टैंड अप कॉमेडी देखने थोड़ी आए यहाँ पे। ठीक है, सो ओके, गुड। सो आंसर दिस। So in the region which is this equatorial region, all right, the surface temperature will be warm. So what will be the temperature of the air? Warm. I need the answer. मतलब ठीक है, at least अपने मन में आंसर करो, लेकिन जरूर करो, because if you don't do this, then you don't understand it. So if that air is warm, that air will tend to expand or contract. So if it expands, it will try to become lighter or denser. If it is becoming lighter, then it will try to rise or sink. इतना तेज भी नहीं बोलना है, मुझे डराना नहीं है यार ठीक है मतलब थोड़ा सा दिख रहे। ठीक है, थोड़ा बिहेव करना भी सीखना है क्लास में ये प्रेप का बच्चों के जैसे नहीं, पूरा सर सब पूरा गला लगा के चिल्ला देंगे आज ही। ठीक है, वेरी गुड। सो इट विल राइज। ओके, सो कैन आई से इन दिस रीजन द एयर शुड बी राइजिंग। ठीक है, अल्टीमेटली दिस इज व्हाट आई वांट यू टू अंडरस्टैंड, बिकॉज आई कुड हैव सेड दिस स्टेटमेंट, in the equatorial region the air rises, but I have not given the answer. ये आंसर आपने दिया है, and now you know why it is rising, है ना? So it is becoming warm, hence it is expanding, hence it is becoming, and hence it is rising. ठीक है, तो अब आप समझ गए, अब आपको मुझसे पूछने का जरूरत नहीं है, राइट? यहां तक समझाने के लिए मुझे आपसे 4 सवाल जरूर पूछने पड़े। अब आप बोलोगे नहीं सर, आप तो कुछ पढ़ाता नहीं हो, सिर्फ सवाल ही पूछते रहते हो। That's what I wanted you to understand, that this is my teaching style. Through my questions I will ask you, right, and make you understand. कोई भी चीज समझने का सबसे अच्छा तरीका ये होता है कि आप उसे क्वेश्चन पूछते रहो, राइट? आस्क appropriate questions so that logic will develop, क्योंकि वो लॉजिक का जो मशीन है वो आपका दिमाग में है। ठीक है, राइट क्वेश्चंस आपके दिमाग में नहीं है, राइट? तो मेरा काम सिर्फ राइट क्वेश्चन देना है, आपका दिमाग का लॉजिक आपको आंसर दे देगा। ठीक है, सो द एयर इज राइजिंग लाइक दिस, एज यू कैन सी हियर। ठीक है, एंड व्हाट विल हैपन इन द, एंड इफ इट इज राइजिंग लाइक दिस, देन ऑल्सो मेक मी अंडरस्टैंड इन द अपर एटमॉस्फेयर will it continue to rise to sun? There will be a limit up to which it will rise and then it will become stable because the surrounding temperature and that air temperature would be same. है ना, जैसा जैसा ऊपर जा रहा है, it will start becoming cooler and then it might come to a region where it becomes stable and then it stabilizes. ठीक है? So there will be a region where it will thermally stabilize itself. Thermally stabilize matlab the temperature is same as the surrounding, so it will not rise any further. Okay, so it will just rise up to a certain limit and then it will stabilize. Now when it is stabilizing, let us say something rising and it stabilizes here. Let me say I leave a balloon and it rises and it goes up to this region and then it stabilizes. And let us say I go on leaving many more balloons behind it. What will happen to that top balloon that has gone first? It will go on the side. Yes or no? So same way is this air which is stabilizing on the top will also try to go sideways. But is it going sideways because of cooling heating? No. It is spreading because of mechanical reason. It was rising because of thermal reason, but it is spreading because of what is the mechanical reason? Pressure. Uska niche ka balloons are putting pressure on it and hence it will go to the side. Do we understand this? Okay. So this air will go on the side, whereas at the same time on the surface, when this air has lifted, this region will have more pressure or less pressure? Huh? If you evacuate some region, it will have more pressure or less pressure? Less pressure. So once there is less pressure, right, what will happen? The surrounding air will try to come in. So we can say that this region, surrounding air will try to come in like this. So this is how the hot region will behave. The equatorial tropical hot region will behave something like this, where the air horizontally will come into that region and vertically go up, and then on the top mechanically it will spread. Is that okay? Now what should happen in the polar region? वहां बताओ क्या होना चाहिए? Temperature is cold. So because of that cold temperature, how should the air behave? It will become cold, so contract or expand, and hence denser or lighter, and hence rise or sink. So in this region the air should move like this, and then on the ground it will spread or it will come in. On the ground the air will come into that region or it will go away from that region where the wind is descending. Away from the region. So here the wind will go like this, and in the upper atmosphere, because air is descending from above, so surrounding air in the upper atmosphere will go which way? Into the region or away from the region? Into the region. ऊपर से तो हवा नीचे आ रहा है, तो ऊपर there will be some mechanical, vacancy created. So that region air will try to come and fill. Is this okay? So now if you see the whole picture, what do you see? Can you see some complete motion? Okay. So we can say that this way a complete motion will take place in the atmosphere somewhat, right? And I will make it dotted line. I will not make it, completely solid line, but I will make dotted because it is somewhat like this, but not exactly like this. So you will have something like this. Okay? Is that okay? So in this region, if I ask you, the troposphere, what is happening? The air is stable or the air is moving? In the whole region the air is, and hence it is mixing, and for mixing there is a word in Greek, tropo. That's why the word troposphere. This is the region of mixing of air. And by mixing, what will it do? Ultimately वो mix हो क्यों रहा है? One region is hot, the other region is, so what is that it ultimately doing? Transfer of heat. Transfer of, and that was the purpose. है ना, हमने पढ़ा था heat transfer वाला टाइम पे, that in this region heat has to be transferred. So hot air is going up, then it is going to the other side, and cold air is coming from there. So there is a complete heat transfer here. Can you see? दिख रहा है ना? And what is assisting that heat transfer? The mixing. And hence this region of mixing of air is called as troposphere. And what is the limit of troposphere? Tropopause, which means above this will there be a mixing? Why? Mechanically, that's the limit up to which the air rises or sinks from. Tropopause is that region. The region up to which the air will rise or the region from which the air will sink and mix. That's it. So this region is called as tropopause. Is that okay? Clear hai? Okay. Yes, batao. Can I tell the abhi wala? This one. So what is happening here? The air is coming from the colder region to take heat. When it comes here, it takes heat. Then it goes up, goes towards the pole, and ultimately passes on some heat to that region. It becomes cold, comes down, again comes back to take heat. ठीक है? जैसा आपने वो bucket mechanism देखा होगा कुआं के अंदर, है ना? Rope and bucket. So the bucket becomes empty, goes down, brings water, pours the water, again becomes empty and goes down. है ना? All right. वो पुराना मूवीज में दिखाते थे ना, there would be this rope and bucket mechanism in the pond, in the what you call as wells, है ना, and there will be an animal going around, है ना, उसी को हम कोलू का बैल बोलते हैं. That whole system is कोलू, and that animal which is drawing that, ठीक है, so something like that. Clear? Very good. So good enough. So इतना लिख लें. Have you drawn this? So we have to write also. थोड़ा सा लिख भी लेंगे यहाँ पे. Okay. Write down. As we see, and please keep some enough space above tropopause. वहाँ पे अभी बहुत कुछ बनाना है. मैंने इसीलिए आपको शुरू में ही बोला है. Tropopause का ऊपर ड्राइंग करना है. I have left space. आपका भी कॉपी में होना चाहिए. ठीक है? So as we see. In the equatorial region, the air gets warm, rises, and rises up to the troposphere. Air gets warm, rises up to the troposphere. And then reaches a height where it stops to further rise. And rather tends to spread horizontally. Also, this upper limit of rise is known as, what do we call this? Tropopause. This upper limit of rise is known as tropopause. Good stuff. Simultaneously along the pole, the colder air sinks, causing mixing of air in the whole troposphere. Troposphere. Okay. And hence the region is known as troposphere. The region of mixing. region of mixing. Okay. Now heights and all I'm not dictating because it is already shown in the diagram. Is that okay? वो dictation तो नहीं चाहिए ना, right? Then further write down. Hence this is the region where almost all of heat transfer takes place. All of heat transfer takes place. In the atmosphere between equatorial up to polar regions. Between equatorial up to polar regions. Right? Now if that is the case and evaporation was a process by which water was getting added into the atmosphere, so we can also say all the water vapor should also be found only in this region and almost all the dust particles should also be found only in this region. Okay, so that also you add. Right? Almost all the water vapor and all the dust particles. Almost all the water vapor and all the dust, almost all the water vapor and dust particles. All the water vapor and dust particles are also found here. Also found here, and hence all the climatic and weather phenomena, all the climatic and weather phenomena also take place here. All the climatic and weather phenomena also take place here. Alright, clear? So everything that we come to experience in the atmosphere is mostly taking place in the troposphere. When you go beyond this, we don't find much phenomena taking place. ठीक है, much, at least not with respect to weather and climate. Is that alright? Very good. Next point. Now you think and tell me, in this region as you go higher, the air should become colder or warmer? Colder. So I can draw, let us say, if I say that this is temperature increasing this side in terms of degree Celsius, right? Temperature increasing this side in terms of degree Celsius, and this side you have already seen height is increasing. Height is increasing. So just assume this is a XY graph. This side temperature, this side height. So what type of graph should I get? इसका ऊपर कैसा? If you go higher, suppose I am going higher, so temperature should increase or temperature should decrease? हाँ? Decrease. तो कैसा ग्राफ बनेगा? है ना? So I can say that in this region, if I try to make the temperature graph should be something like this. Yes or no? Temperature decreases with height. है ना? So as you go higher, the temperature is decreasing. Can you see? Is that okay? So this is the temperature graph in this region. That this is how the temperature varies in the troposphere. ठीक है? कोई डाउट है? चेहरा पे तो डाउट दिख रहा है. टेम्परेचर ये इधर इंक्रीज हो रहा है ना, और हाइट इधर इंक्रीज हो रहा है, तो जैसा जैसा ऊपर गया तो टेम्परेचर डिक्रीज होगा ना. ठीक है? So this is how the temperature decreases. So this is what we have to write again. Hence, in the troposphere with height, हाँ जी बोलो बोलो, डाउट है कुछ? हाँ? ग्राफ. अभी टेम्परेचर क्या हो रहा है? अभी क्या हो रहा है? इंक्रीज हो रहा है. ये जो है, ये इधर टेम्परेचर इंक्रीज ऐसा दिखाया है. तो जस्ट We are not moving towards. That's what I said. अभी ध्यान से सुनो. आप लोग क्या गड़बड़ कर रहे हो ये अभी समझो. आपको ये लग रहा है I'm going toward pole. I said this is a x axis. Assume this now to be just for temperature. Assume this not to be the equator and pole. Assume it to be x-axis and assume this to be, बनाते हैं ना x-axis y-axis. तो अगर मान लो इधर को टेम्परेचर बढ़ता हुआ दिखाना है ग्राफ में, है ना, तो ऐसा देखो, इधर समझो, मान लो ये हमने ग्राफ बनाया ऐसा, राइट. ये है आपका हाइट और ये है आपका टेम्परेचर, ठीक है. एंड आई एम सेइंग टेम्परेचर के साथ हाइट वो हो रहा है, तो कैसा ग्राफ बनेगा? ऐसा ही बनेगा ना. एज यू गो हायर टेम्परेचर इज डिक्रीजिंग. तो वही चीज मैं वहां बनाने का कोशिश कर रहा हूं. इज दैट ओके? क्लियर? वेरी गुड. सो कमिंग बैक, so here I am drawing it with respect to this temperature and that height. ऐसा ये x मतलब you are not going towards pole or something. Keep that in mind. Okay. So now coming back. अभी clear है? हाँ? Right? Anyone still having any doubt? पूछो. नहीं? Clear है? Very good. So now tell me. That's what we are writing. So I think क्या बोला मैंने? As we go higher. आप बोलो. बस इतना ही लिखा है ना, as या कुछ hence. अच्छा, hence लिखा है तो सर. Hence, as we go higher, the temperature, as we go higher, the temperature decreases with altitude. Temperature decreases with altitude at a nearly fixed rate, of 1 degree Celsius decrease, at a nearly fixed rate of 1 degree Celsius decrease for every 165 meter. 1 Celsius decrease for every 165 meter increase in height. 165 meter increase in height, comma, known as normal lapse rate. Known as normal lapse rate of temperature. Normal lapse rate of temperature. Okay, so temperature wise, up to this region you find the temperature to be decreasing with height. Clear hai? Okay, now above this what do we have? When, हाँ जी बताइए. इक्वेटर पे जो एयर स्प्रेड हो रही है वो नहीं, टेम्परेचर की वजह से ऊपर. हाँ, यहां पे उल्टा हो रहा है क्योंकि यहां पे इन दिस रीजन एयर इज गोइंग डाउन, सो दिस रीजन विल हैव अ रिलेटिव लो प्रेशर. सो फ्रॉम द साइड एयर विल come to fill that low pressure, then only air can further go down. ठीक है, तो यहां पे जमीन पे हाई प्रेशर है, ऊपर लो प्रेशर है, बट वो लो प्रेशर किसका हिसाब से? इधर से, क्योंकि यहां पे हाई है तो यहां से हवा आ रही है और यहां पे लो है तो यहां पे हवा पहुंच रही है. ओके, राइट, गुड. सो नाउ एज यू गो हायर, which other region do you find? Please see. So when you go above this, then you come into the second region, right, known as, very good, stratosphere, right? So stratosphere. Stratosphere. And the stratosphere is up to a height of 50 kilometer from the surface of the earth. Up to 50 kilometer from the surface of the earth, right? So up to 50 we find stratosphere. This is straight, right? So lower part of stratosphere is tilted, upper part of stratosphere is straight. नीचे वाला पार्ट tilted है ना, ऊपर का पार्ट straight है. Okay, then हाँ 60 नहीं 50 है. Both side it is 50. The height is same, right? At both the sides it is 50 kilometers. All right. So आपका एनसीईआरटी के हिसाब से वी आर मोस्टली फॉलोइंग द डेटा गिवन इन योर एनसीईआरटी जीसी लियोंग, वो वाला डेटा है. ठीक है, बहुत सारा जगहों पे आप और देखोगे तो हो सकता है कुछ चेंज डेटा मिले, बट ब्रॉडली और एनसीईआरटी एंड जीसी लियोंग गिव्स यू दिस डेटा, सो वी फॉलो दैट ओनली. तभी मैं बार बार बोल रहा हूं कि हमें अपना एग्जाम के लिए सिर्फ एनसीईआरटी और यूट्यूब पे डिपेंड नहीं करना है. ठीक है, यूट्यूब और रेडिट और इस पे नहीं देखना है, उसके ऊपर एलोन मस्क के बच्चों को पढ़ने दो. आप लोग एनसीईआरटी पढ़ो, क्योंकि आपके पापा मम्मी पीछे स्पेसएक्स नहीं छोड़ जा रहे. कहां पे नहीं आता है, कहां पे वेरिएशन, तो क्या दिक्कत है? फ्रॉम द, क्या बोला मैंने? अच्छा ठीक है, अगला बार से ठीक है, एकदम क्वेश्चन रेस करने के पहले से ध्यान से सुनना है कि बोला क्या था. ऑलराइट, दैट्स ओके, क्वेश्चन पूछ सकता है, लेकिन ऐसा ही नहीं जबरदस्ती क्वेश्चन नहीं क्रिएट करना है. नहीं नहीं, तो सुनना है ना, इसीलिए तो क्लास में आए हो, तभी तो सामने बिठाया है. ऑनलाइन वाले बेचारे आपसे कम पैसा दिए हैं, वो इसीलिए क्योंकि वो बेचारे कुछ भी बोलेंगे मेरे को सुनाई नहीं दे रहे, मेरे को पढ़ना पड़ता है. आपको सामने बिठाया है, यहाँ पे उल्टा पुल्टा नहीं बोल पाएंगे. ठीक है. ओके चलो, तो ओके गुड. सो दिस इज योर stratosphere. Now what is the special thing about the stratosphere region? One is the upper limit of stratosphere is stratopause. Stratopause is the upper limit of stratosphere which is at a height of 50 kilometers from the surface of the earth. ठीक है, and the region of stratosphere is also known for ozone gases. This is the region where we find all the stratospheric ozone of the earth. All the stratospheric ozone of the earth. And sir, why are you saying stratospheric ozone? Because you find ozone also in troposphere. In troposphere also we find ozone. We call it as bad ozone. ठीक है, bad ozone बोलते हैं उसको. और stratosphere में कौन सा ozone है? Good ozone. Why good ozone? Because it protects us from UV radiation. ठीक है, whereas the ozone which is in the troposphere is bad because it does not protect us. Secondly, it harms us. ठीक है, आप ओजोन इनहेल नहीं कर सकते, करोगे तो दैट इज बैड फॉर यू. ठीक है, सो इज दैट ओके? डू वी गेट इट? ठीक है, सो इन द स्ट्रेटोस्फीयर रीजन वी हैव द व्हाट? ओजोन. दिस रीजन, दिस होल रीजन वी हैव ओजोन गैस. एंड व्हाट इज द रोल ऑफ ओजोन गैस? इट प्रोटेक्ट्स अस फ्रॉम यूवी रेडिएशन. ठीक है, सो प्लीज ड्रॉ. So this is the layer of ozone. Layer of ozone. There is this layer of ozone which protects us from UV radiation. ठीक है. Now, where is the UV radiation coming from? Sun, which means above the above the stratosphere or below the stratosphere. So the UV radiation is coming from above the stratosphere. ऐसा ऊपर से आ रहा है. ठीक है, एंड व्हाट हैपेंस टू दिस यूवी रेडिएशन इन द ओजोन? होता क्या है? व्हाट डज द ओजोन डू विद द यूवी रेडिएशन? जस्ट अंडरस्टैंड ऑल ऑफ यू. ठीक है, द वंस सम ऑफ यू माइट बी नोइंग दिस रिएक्शन, दिस इज वेयर आई हैव टू टेल स्लाइटली. ठीक है, सो व्हेन द यूवी रेडिएशन हिट द ओजोन, राइट, द ओजोन अब्सॉर्ब्स द यूवी रेडिएशन. व्हाट डज इट डू? अब्सॉर्ब्स द UV radiation and breaks that ozone molecule. ठीक है, so that ozone molecules get broken in the process. ठीक है, right? So ozone will absorb the UV radiation and break the molecule and release heat energy. So it basically absorbs the UV radiation and releases heat energy, or simply said converts UV radiation into हीट एनर्जी. क्योंकि दोनों का दोनों रेडिएशन है, दोनों में एनर्जी है. सो व्हाट इट डज? इट टेक्स द हाई एनर्जी रेडिएशन एंड रिलीजेस लोअर एनर्जी रेडिएशन. हीट एनर्जी कौन सा फॉर्म में होता है? मैंने आपको बोला था शायद पिछला क्लास में, इंफ्रारेड. ठीक है, सो इट रिलीजेस इंफ्रारेड रेडिएशन और लो एनर्जी रेडिएशन और हीट एनर्जी रेडिएशन. ठीक है, सो बेसिकली नाउ सी हियर, the UV radiation is coming, it is getting absorbed, and then that UV radiation energy is getting released to the surrounding as heat energy. So if this is getting released to the surrounding as heat energy, then what will happen to this region? It will become warmer or colder? So which region of the stratosphere will be warmer? Upper region. And which region of the stratosphere will be colder? Why? Because gradually less and less UV radiation will reach the lower region because most of it is absorbed in the upper region. है ना? जैसा अर्थ का सिस्टम में डस्ट ज्यादातर नीचे था और ऊपर डस्ट वाज लेस. Here UV radiation absorption is more on the top and less absorption in the lower. So which region will be hotter? So if I make the temperature graph for temperature here, how should it look like? As the height increases, temperature should be constant, reducing or increasing. So the graph will become something like this. है ना? So in the stratosphere, the temperature graph is different. Troposphere, the temperature graph is. This is why this graph is on the basis of, or this classification is on the basis of temperature. आपने शुरू में लिखा है ना? On the basis of temperature. So this classification is on the basis of temperature. ठीक है, बिकॉज इन डिफरेंट रीजन्स टेम्परेचर विल बी डिफरेंटली बिहेविंग. ठीक है, नीचे वाला रीजन में इट इज इंक्रीजिंग विद हाइट, ऊपर वाला रीजन में इट इज डिक्रीजिंग विद हाइट. उल्टा बोल दिया. ठीक है, विच एवर वे. राइट, सो इज दिस ओके? एज द at the tropopause, the temperature will be low, right? Constant, are you saying? Yeah, there will be a value to it. The value I haven't given, I'll give you. अभी देते हैं. ठीक है, so here the temperature will be low and here the temperature will be higher in that region. ठीक है, so just write down that in the stratosphere, which stretches up to the stratopause at 50 kilometers, which stretches up to stratopause at 50 kilometers from surface of Earth, the region is full of ozone. The region is full of ozone where the ozone absorbs the UV radiation, coming from the sun, and hence the upper part of the ozone layer gets more heated as compared to the lower part. This is because UV radiation is coming from above. UV radiation is coming from above, and it is converted into heat energy by ozone. It is converted into heat energy by ozone. Full stop. Therefore, the temperature increases with height. Therefore, temperature increases with height in the stratosphere. Temperature increases with height in the stratosphere. Okay. Now, how much is the temperature at different regions? Please see. The stratopause temperature is around minus 2.5 degrees Celsius. It is minus 2.5 degrees Celsius. Whereas the tropopause temperature at different regions is different. How? At pole, it is minus 80 degrees Celsius. At the equator, extremely sorry. बिल्कुल ठीक है. So at the equator it is minus 80, whereas at the pole it is minus 45 degrees Celsius. And minus 45 is warmer than minus 80. So the polar tropopause is warmer than the equatorial tropopause. ठीक है? Why? Because of height. Because this is 10 kilometer higher. So temperature will fall by that ratio. Every 1 kilometer temperature is falling by 6.5 degrees at the lapse rate. 165 meter में 1 degree. So 1 kilometer में nearly 6 to 6.5 degree. So in 10 kilometer, how much more it will fall? Around 65 degree fall. Because tropopause is 10 kilometer higher at the equator than the pole. है ना? Is that okay? So here the temperature is around minus 80 to minus 45, and there the temperature is minus 2.5. So minus 2.5 is cold, but that is warmer as compared to tropopause. Is this understood? ठीक है? So this much is clear to us. Do we understand this? ठीक है? Now what is the region above it? इसका ऊपर कौन सा region है? Mesosphere and all. So this will continue to go, but I'll give you a break here. ठीक है? ब्रेक चाहिए होगा, बहुत देर से पढ़ाई कर रहे हो. हाँ जी. What is the maximum temperature in the troposphere? The maximum temperature in the troposphere will always be on the surface of the earth. Isn't it? Because as you go higher, the temperature is decreasing. And what is the minimum temperature in the troposphere? Minus 80 degree. ठीक है? लॉजिक भी लगाना है थोड़ा थोड़ा. हाँ जी बोलो. In the troposphere, yes, we'll come to that. वो अभी आएगा. ठीक है? So just take a quick 10-minute break. It is 47, so let us meet around 57. 10 मिनट में आ जाइए. Slightly modified है. तो क्या दिक्कत है? अच्छा, हाँ हाँ हाँ, ठीक है. वो ग्राफ का वैल्यू आप बोल रहे हो कि सेम नहीं है. वो माइनस 2.5 है और यहाँ पे नीचे तो उतना नहीं है, यही बोल रहे हो ना? कोई बात नहीं, वो थोड़ा ग्राफ बनाने में थोड़ा गलती मेरा भी मान जाओ. बना सकते हैं, कोई आपको नहीं रोकेगा. ठीक है? बुक्स में भी देखोगे तो कुछ कुछ ऐसा वैसा ही थोड़ा बनाया हुआ है अलग अलग बुक में. सो यू जस्ट राइट द राइट वैल्यू देयर, दैट्स इट. ग्राफ एग्जैक्टली वो देखेगा नहीं कि क्यों इधर बनाया है और बोल उधर रहा है. ठीक है? डायरेक्शंस राइट होने चाहिए. हाँ जी बोलिए. ब्रेक के बाद आओ यार, मुझे भी थोड़ा ब्रेक दो. ठीक है? चलेगा? राइट, आई थिंक मैंने ज़्यादा लंबा ब्रेक ले लिया. So now let us come to the next region. So when you go beyond this stratosphere, right, and the stratopause, you come to the third region, which is the mesosphere and the mesopause. Okay. Meso का मतलब क्या होता है? Middle, and hence this is the middle layer. ठीक है? So this is the nearly middle layer of the atmosphere, because above it you have two and below it also you have two regions. ठीक है? So this is the middle region, and it extends up to a height of 80 kilometers from the surface of the earth. Right? So extends up to 80 kilometers from the surface. Right? And in this region there is no ozone, and the temperature change because there is no ozone, and also as you go higher and higher the temperature will go on becoming colder. Okay. So here the temperature continues to fall again. Right, this is a region of temperature fall continuously. Alright. And what is the minimum temperature that you find at the top of the mesosphere, the region which we call as mesopause? At the mesopause, what is the minimum temperature? Minus 100 degrees Celsius. So here the temperature falls to the lowest value of minus 100. On the earth, nowhere else you find temperature colder than this in the whole earth system, naturally. Okay? So this is the naturally occurring lowest temperature region in the earth system, right? Not on the land, but in the system. Okay? So mesosphere, and hopefully we understand the region, the temperature goes on decreasing because there is nothing specific happening. Alright, and most of the dust particle and space falling satellites and all, they tend to burn in this up to this region. Most of the particles falling, they tend to burn up to maximum up to this region. They generally don't come into the the stratosphere and the troposphere. They burn by the mesosphere. Anything falling from the space. ठीक है, क्योंकि इसी के ऊपर वो अभी कार्बन लाइन हमने पढ़ा था 100 kilometers. Right, so up to, so after that when it starts falling, it comes into this 80 to 50 wala region, and there it burns completely. ठीक है, that's where it objects tend to burn. All right, clear? Now what do we have above the mesosphere? When you go above the mesosphere, you come up to a height of 400 kilometers. 400 kilometers. You have the region known as thermosphere. Thermosphere. Right, the thermosphere region is there. Okay. Now, what is the characteristic of thermosphere? In the thermosphere, there are very few particles of gas which are found, because you are coming into the space now. तो कार्बन लाइन के हिसाब से आप स्पेस में हो मोस्टली. Just the lower 20 kilometer is atmosphere, and beyond that when you go, you are into space, which means the particles are very less, right? And because of this region has very high temperature also. Why? Because very few particles go on to absorb the sunlight and they become very heat. छोटा सा particle है, उसको बहुत सारा heat मिल गया from the sunlight. So that particle becomes very heated up. So in this room maybe 10 particles will be there, but those 10 particles will be extremely heated up. ठीक है? In this room right now there will be millions of particles, but in that kind of a region when you go, you will find very few particles in the space. And those themselves might be extremely heated up, and the temperatures might be as high as up to 1500 degrees on the top of thermosphere. So on the top of thermosphere, the temperature might be as high as 1500 degrees Celsius. Okay, so in this region, the particles get very heated. How? Very simple. You take a tawa and heat it up, and on that tawa you put 10 grains of salt. गिन के 10 grain डाल दो. What will happen to that salt particles? In 1 second, they will become heated up and they will start bouncing. देखा है ना? If you take a big tawa and on that, when it is extremely hot, you just spread 10 grains of salt. They will become suddenly very heated up. This region also behaves exactly almost the same way. That there are so less gas particles that they become extremely heated up. ठीक है? And the temperatures might be as high as 1500. Now at that temperature, whatever particle is there, that will get ionized. Because they are so heated up that they become ionized. And hence, in this region, all the particles are ionized. And hence the region is called as ionosphere also. Okay? So the thermosphere region is also known as ionosphere for the simple logic of all the gas particles being ionized. Okay? So please do draw right the region. Very few particles are there and they are extremely heated and hence ionized. Right? So ionosphere. And this the ionized particles, when we send radio wave signals from the earth, okay, let us say we are sending some radio wave signals from the earth toward the sky. So those radio wave signals get reflected by the ions. Right? Radio wave signals are bounced back or reflected back to the earth. So this is the importance of ionosphere, that it tends to reflect back the they tend to reflect back the radio signals. But kaun sa radio signal? For example, if you go into the interview or in the prelims, they ask you, we hear the FM band, which is a radio band, because of ionosphere. Is this right or wrong? Wrong. क्यों? खुद सोचो. आपको FM band कहाँ सुनाई देता है? Only in the urban areas. The moment you start going away from the urban areas, do you hear the radio signal of the FM band? Why? Because they are tower based. They are tower based systems. आपको गांव में कौन सा रेडियो सुनाई देता है? मतलब until unless your गांव is close to the city. In the far away villages, which radio signals do you get? You get BBC. इस टाइप का सिग्नल्स है. सो दे आर नॉट ऑन FM बैंड, है ना? कल जाके चेक करना है कौन सा बैंड पे आते हैं वो. दीज आर द फाइनर क्वेश्चंस दे कैन आस्क यू. राइट? सो योर FM बैंड और FM रेडियो सिग्नल्स आर नॉट, फ्रीक्वेंसी मॉड्यूलेटेड सिग्नल्स आर नॉट रिफ्लेक्टेड बाय ionosphere. ठीक है? द लो एनर्जी सिग्नल, FM बैंड इज अ हाई एनर्जी सिग्नल, दैट्स व्हाई द क्वालिटी ऑफ दैट सिग्नल इज गुड. दैट्स व्हाई यू गेट गुड साउंड फ्रॉम द FM बैंड. ठीक है? जो लो एनर्जी सिग्नल्स है, राइट, उनका क्वालिटी इज बैड, बट दे कैन बी रिफ्लेक्टेड बाय ionosphere also. So what we do, we don't create stations for them. We have a sending station and then we send it into the space, they bounce and then they are uniformly spread in a large region. So पूरा इंडिया में वो रेडियो सुनाई देगा, कहीं पे भी हो आप, माउंटेन टॉप पे भी बैठा रहेगा तो वहां पे भी you will get that radio. Do you understand this? आ रहा है समझ में? ठीक है? So we don't get the FM band. अब बाकी और कौन कौन सा बैंड होता है वो आपको खुद ढूंढना है. ठीक है? ढूंढो. Give me the answers. हाँ, नेक्स्ट क्लास में लेकर के आना है कि कौन कौन सा और बैंड है. फॉर एग्जाम्पल विच आर द रेडियो channels. You ask your people, बहुत सारा इस क्लास में I assume many people would have people in the villages. You ask those people कौन कौन सा रेडियो आ रहा है आपके इधर, कौन सा बैंड पे सुनते हैं. देखा है ना वो गांव के अंदर दे विल हैव दिस रेडियो सिस्टम, उसके अंदर वो ऐसा ऐसा ट्यून करके. आजकल तो मोबाइल में हो गया है, बट उसके अंदर यू सिलेक्ट एंड पीपल सिट अराउंड इट एंड लिसन. आजकल गांव में सबकी जगह टीवी हो गया. आप बोलो सर आजकल तो हमारा गांव मॉडर्न हो गया है, वहां पे नोबडी इज लिसनिंग टू रेडियो, एवरीवन इज ऑन मोबाइल एंड ट्विटर एंड व्हाट्सएप एंड इंस्टाग्राम. हाँ, फसल उगाते ही फोटो खींच के डाल देते हैं, ये देखो. हाँ, सीड्स आर स्प्राउटिंग. हाँ, सुबह सुबह भैंस को लेके जा रहा है, उसका भी फोटो खींच के. बफेलो गोइंग टू द फील्ड. हम लोग इतना ज्यादा फोटो में विश्वास करने लगे हैं. हर काम पहला फोटो जाना चाहिए, काम होना हो, है ना. यस बोलो. When the ionosphere is 1500 degrees Celsius, material don't burn there because of the temperature, they burn because of friction. और फ्रिक्शन के लिए पार्टिकल चाहिए, और आयनोस्फीयर में कम पार्टिकल है. एक बात बताओ, तवा के ऊपर नमक डाला 2 दाना, वो दोनों दाना बिल्कुल 100 डिग्री पे उठा के आपके ऊपर फेंक दिया, आप जल जाओगे. हाँ, 2 छोटा दाना समझते हो ना, those grains of salt, I just take 2 grain of salt, just assume that sir you are able to do, मान लो मैं कर सकता हूँ. So I take 2 grains of salt and I put it on a 100 degree tawa, and then I throw those 2 grains on you. Will you get a burn? हाँ, इतना छोटा छोटा वो जो 2 दाना सॉल्ट होता है वो आपके ऊपर गरम गरम फेंक दिया, जलेगा या नहीं जलेगा? नहीं जलेगा. तो इसीलिए वहां जाके जले वालेगा कोई भी नहीं. भाई वो पार्टिकल ही बहुत कम है. ठीक है, जेन्युइन क्वेश्चन है कि सर उधर है तो जल क्यों नहीं रहा है. हाँ, स्पेस स्टेशन भी वहीं पे है, पार्टिकल्स इतना कम है दैट यू डोंट गेट अ बर्न. ऑलराइट यार, जरूरी तो नहीं कि मेरा फोन बजे तो आप भी अपना फोन बजा डालो, वो भी गाना वाना के साथ. ओके, और एक तो इतना अच्छा अच्छा सॉन्ग्स भी आप लोगों ने अपना रिंगटोन डाला हुआ है. दैट्स ओके. ठीक है, एक और क्वेश्चन है, बोल डालो. आयनोस्फीयर, विच काइंड ऑफ? आयोनाइज होने का मतलब छोटा होना तो नहीं होता है. केमिस्ट्री पढ़ो, आयोनाइज का मतलब क्या होता है. ठीक है, गैस को आयोनाइज होने का मतलब छोटा होना नहीं होता है. आयोनाइज का मतलब होता है चार्ज डेवलप करना. हाँ जी बोलो. चार्ज होता होगा, उसका कुछ प्रोसेस है, देखो क्या करते हैं. सैटेलाइट इतना बड़ा है, वो उतना हीटअप नहीं हो पाता है. स्मॉल पार्टिकल्स गेट हीटेड अप. ठीक है, नॉट बिग वंस. गैस पार्टिकल्स वो आयोनाइज होते हैं, सैटेलाइट नहीं, बिकॉज सैटेलाइट इज वेरी बिग. ठीक है. Yes, we do develop different kind of material and we have different kind of protective layers around the systems that we send in space. वो सारा protective layer इसीलिए हम बनाते हैं. ठीक है, और कुछ आगे बढ़े. बोलो बोलो, listening. Yes, the ionosphere itself has the ionized layers A, B, D, ऐसा करके बहुत सारा layers है उसका, बहुत सारा है. वो इसका ऊपर भी जाता है. ठीक है, और कुछ वो ट्रांजिशन जोन से हल्का सा नीचे भी है, बहुत सारा है, बट वी डोंट गेट इनटू दोस डिटेल्स, दैट इज साइंस. ठीक है, एनी अदर क्वेश्चन? मतलब यू हैव सम क्वेश्चन रिलेटेड टू दिस और दिस वाज द क्वेश्चन? ओके ओके, या सो देयर आर डिफरेंट लेयर्स ऑफ आयनोस्फीयर, बट दैट यू डू इन योर साइंस पार्ट, नॉट इन योर. ठीक है, आयनोस्फीयर का पार्ट कौन कौन सा है वो सब वहां पढ़ो. ऑलराइट, एनीथिंग एल्स? नथिंग. ठीक है, सो गुड. सो आगे बढ़े. राइट, सो व्हाट डिड वी अंडरस्टैंड इन टर्म्स ऑफ एटमॉस्फेरिक लेयर्स इन द थर्मोस्फीयर? हमें लेयर के हिसाब से क्या क्या समझ में आया? सबसे पहला, फ्रॉम वेयर टू वेयर? हाइट. 80 to 400 kilometer. What is the state of material? Very few material. The particles are very few. And what state are they in? They are in a ionized state. And why are they ionized? Because there are very few particles, so they are heated up and hence ionized. Okay? Because of ionization, what do they do, which is more important to us? For us, we get the radio waves. In nature also they create another phenomena that is called as the aurora. The phenomena of aurora in nature is created in the ionosphere. वो भी लिखना है, ठीक है? That the phenomena of auroras, the phenomena of aurora, A-U-R-O-R-A, the phenomena of aurora, A-U-R-O-R-A, phenomena of aurora is created in the ionosphere. Aurora is created in the ionosphere due to the cumulative effect. I'm simplifying and giving you, okay? Due to the cumulative effect of interaction of the ionized layer, ionized particles, cumulative effect of interaction of the ionized particles to solar charged particles. Solar charged particle, तो ये दोनों तो charged particle हो गए, right? The ionosphere charged particle and the solar charged particle and Earth's magnetic field. Earth's magnetic field. So you have one magnetic field and you have electric particles. So when electricity and magnetism, their fields interact, what is produced? Electromagnetic radiations. And light is a electromagnetic radiation. तो वहां पे क्या प्रोड्यूस होगा? When the ionosphere interacts with solar charged particles and Earth's magnetism or Earth's magnetosphere, what will be produced? Light. And that light we call as aurora. So that aurora phenomena is created here. This is the simple explanation. I am not going into the physics. मैं बिल्कुल सिंपल तरीके से आपको समझा रहा हूँ. Light is nothing but electromagnetic radiation, which is created due to electric field and magnetic field interacting together. ठीक है? So what have we written? Cumulative effect of interaction of ionosphere or the ionized particles. Second, solar charged particle, and third, Earth's magnetic field, creating the electromagnetic light. Electromagnetic light, known as auroras. ठीक है? And where is this phenomena most prominent? In the polar region. This is observed in the polar region. ठीक है? Polar region. Also known as northern lights. Or polar lights. Northern lights or polar lights. ठीक है? Clear? Also, come again? Because they are seen in the north. South we see, but first they were seen in north. In the north we are seeing it for centuries, generations. South में तो हम अभी गए हैं. एक को कोलंबस और उन्होंने ढूंढा, दूसरा ऑस्ट्रेलिया किसी ने ढूंढा. तो ये तो बहुत पुराना फाइंड नहीं है ना. ठीक है? तो नॉर्थ में वी सी इट फॉर वेरी लॉन्ग टाइम. ठीक है? So we call it as northern lights. Is that all right? Right? Should we go beyond this? So which is the next layer? Above this you have the last layer. Very good. इसका ऊपर कौन सा है? Exosphere. And exosphere stretches up to a height of 3500 kilometers. Exosphere कहां तक है? 3500 kilometers. ठीक है? That is exosphere. And this is the most rarefied layer. Most rarefied. As if there is hardly any particle. But we do find some hydrogen and helium there, so we call it as outer limit of atmosphere. ठीक है? So most rarefied, 3,500 kilometers. And here also the temperature goes on to increase. अच्छा, thermosphere में हमने क्या देखा था? The temperature was increasing, and here also, and up to what degree was it increasing? 1500 degrees in the thermosphere. Here it increases further up to 5000 degrees Celsius. Here the particles get so heated that they might be as high as 5000 degrees Celsius. That's the reason why we find a layer of the ionosphere even in the exosphere. जो आप पूछ रहे थे ना कि उसका layers है, तो उसका कुछ layers exosphere में भी मिलता है. ठीक है? Alright? Is this clear? So that's it. इतना ही है. That's the whole thing. Now what is this importance of 5000? मैंने आपको बताया एक बार पहले. 5000 degree or 5000 to 5500 degree is the temperature found in 3 regions of importance for your prelims. The top of the atmosphere, center of the earth, surface of the sun. ये तीनों जगह का टेम्परेचर सेम ही है. जस्ट फॉर कीपिंग इन योर माइंड. 5500 से 5000 डिग्री सेल्सियस, ये तीनों जगह का टेम्परेचर यही रेंज में है. ठीक है? जस्ट टू रिमेंबर द सेंटर ऑफ द अर्थ, द आउटर मोस्ट ऑफ द अर्थ एंड द सरफेस ऑफ द सन. ठीक है? तो ऐसा याद रख सकते हैं. इजी टू रिमेंबर. Good enough. So with this we are done with the vertical structure of the atmosphere. Now let us come to the next part. The next thing after this is heating and cooling of the atmosphere. हाँ जी बोलिए. Listening, listening. बोलते जाओ, सुन रहा हूँ. There are temperature differential in the tropopause. Differential मतलब? Yes. At different latitude there are breaks. As in? Okay, okay. Yes, yes, yes. ठीक है. Very good, good. Yes, yes, yes. It is very important and you will require it for monsoon. ठीक है? So now this is something that earlier in some batches I used to do it here. Now I find it more relevant because I have to talk of it in monsoon. तो कई बार मैं वहाँ बोल देता हूँ. ठीक है? But now that you have taken it up, so now let me say this here itself. यहीं लिख लो. But then you have to refer because then I have to explain again there. ठीक है? Now what is happening is, please listen all of you. At the pole, the troposphere top is cold, at 8 kilometers. We know this. Why? Because pole is always cold. तो वहां पे height 8 kilometer है. And equatorial region is hotter, so the air tends to rise more, and it goes up to 18 kilometer. Why? Because equator is always hot. What happens in the middle region? The middle region in winter is cold, and in summer it is hot. So in the summer, the height should be more or less? More. Why? Because hotter regions have higher tropopause and colder regions have lower tropopause. So the middle region in the summer will have higher tropopause, and the middle region in the winter season will have lower tropopause. How much? The average height is 13 kilometers. In the summer this becomes as high as 15 kilometers, and in the winter it becomes as low as 12.5 kilometers. ठीक है? तो ये ऐसा होता है. We will talk of this in monsoon again. जब हम monsoon करेंगे, so there we'll write it. But if you need to write, यहाँ मन कर रहा नहीं लिख लेते हैं तो लिख लो, आपका ऊपर है. ठीक है? That the tropopause height, the tropopause height in the mid latitude varies between summer and winter. Varies between summer and winter. Tropopause height in mid latitude varies between summer and winter. In summer, rises up to 15 kilometers. Summer, it rises up to 15 kilometers. Whereas winters, it lowers up to 12.5 kilometers. Lowers up to 12.5 kilometers. ठीक है? Average height is 13 kilometers. Average is 13 kilometers. So Now coming to heating and cooling of the atmosphere. हाँ जी बोलो. Is there any relation between tropopause and thunderstorm? First of all, what is a thunderstorm is something that we have not covered. तो पहले जब हम thunderstorm करेंगे, you keep this question for that time, we'll take it up. वहाँ देखते हैं, क्योंकि अभी मैं आंसर कर भी दूंगा तो many of them don't understand what is thunderstorm, है ना? So वहाँ देखते हैं. It is good that some of you have already read your NCRTs, है ना? थोड़ा मोड़ा पढ़ा है, that always helps. And this is exactly what I expect from most of you, कि थोड़ा सा पढ़ के आओ तो it will help. और अगर नहीं तो एटलीस्ट क्लास के साथ साथ पढ़ते रहो. डोंट लैग टू मच बिहाइंड. ठीक है. द वंस हु गॉट टाइम टू रीड बिफोर, मे बी दे माइट हैव डन देयर ग्रेजुएशन अर्लियर और व्हाटएवर, और दे माइट हैव पुट दैट एक्स्ट्रा एफर्ट एंड डन इट. अगर आपने नहीं भी किया है तो घबराना नहीं है, बट क्या करना है, एटलीस्ट क्लास के साथ साथ करते जाओ. ठीक है. डोंट क्रिएट टू मच ऑफ बर्डन. ऐसा नहीं कि नहीं पढ़ रहे, उससे फिर गड़बड़ है. साथ कर सकते हैं. So either do the NCERT in the class. If you think कि NCERT नहीं समझ में आता है तो क्या करना है, क्लास के बाद जाके पढ़ लो, but please do read. ठीक है. So mix up, because once you understand the concept in the class, then when you go and read the NCERT, you will find two things. One, you will find many new points which I am not doing in the class. ठीक है. New points as in new facts and all will come. ठीक है. And you might have the feeling that NCERT भी पढ़ लिया है, क्योंकि ज्यादातर टॉपर क्या बोलते हैं, हमने एनसीईआरटी पढ़ा है. ठीक है ना. तो इसीलिए एनसीईआरटी भी पढ़ना है साथ साथ. ठीक है. और साथ साथ करते रहो. ऑलराइट. कम बैक. हीटिंग एंड कूलिंग ऑफ एटमॉस्फेयर. हाँ. टेम्परेचर ऑफ होल एक्सोस्फेयर इज, टेम्परेचर स्पेस का होता है या पार्टिकल का होता है? तो फिर किसका, वही तो मैं पूछ रहा हूं, टेम्परेचर होता किसका है? फर्स्ट ऑफ ऑल यू हैव टू अंडरस्टैंड टेम्परेचर होता किसका है. किसका होता है, स्पेस का या पार्टिकल का? टेम्परेचर किसके साथ होता है? हीट कौन ऑब्जॉर्व करेगा, स्पेस या पार्टिकल या मैटर? मतलब वही पार्टिकल और मैटर, स्पेस या मैटर? आंसर आपने खुद ही दे दिया. थोड़ा सोचना है क्वेश्चंस के ऊपर. ठीक है. कोई सा भी क्वेश्चन, राइट. मेनी टाइम्स यू विल गेट द आंसर बाय थिंकिंग, राइट, कि किसका हो सकता है, राइट. और अगर नहीं क्लियर है तो ढूंढो, बिकॉज दिस विल हैपन इवन एट होम. वहां पे भी पढ़ते पढ़ते डाउट आएगा ना. सो देन व्हेन यू सर्च कि अच्छा टेम्परेचर, पहले तो ये, इफ माय क्वेश्चन इज टेम्परेचर कितना होना चाहिए, तो आप ये पहले पूछो किसका होना चाहिए. ठीक है. इसी टाइप का डिफरेंट क्वेश्चंस. आई एम जस्ट ट्राइंग टू मेक यू अंडरस्टैंड थ्रू योर ओन क्वेश्चनिंग हाउ टू रीच आंसर्स. ठीक है. तो अभी आंसर मिला, किसका होगा? गुड. चलो. सो कम टू, और कोई डाउट? अभी मैं फिर से बोलूंगा नहीं, 3 बार बोल चुका हूं, फिर क्वेश्चन आता है. पक्का? चलो. सो शुड आई से लेट अस कम टू हीटिंग एंड कूलिंग ऑफ एटमॉस्फेयर? वेरी गुड. सो लेट अस कम टू हीटिंग एंड कूलिंग ऑफ एटमॉस्फेयर. ऑलराइट. सो what is the source of heating of the atmosphere? Source of heating of the atmosphere is mainly the sun. Almost most of it comes from the sun, though some of it might come from Earth's interior and all, but that is negligible. So you should know that it is there, but it is negligible. Okay. So almost all the heat to the atmosphere comes from the sun. Some comes from the earth also, but that is negligible. ये लिखना है. ठीक है. So almost all this heat comes from the sun. Though a negligible amount comes even from the Earth's interior. In the form of Earth's interior. So when we say most, it almost comes from the sun. In what form does it come from the sun? It comes in the form of radiations. sun as solar radiation, comes from the sun as solar radiation. ठीक है? And till now, what all radiations have we taken from the sun? So we have seen the UV radiation, and we have seen infrared radiation. Infrared brings the heat. The heat is mostly brought directly by infrared. ठीक है? And light brings the Vibgyor wala light brings you the visibility. ठीक है? Your eyes are sensitive to the light radiations. ठीक है? If you read about the evolution of eye, so how did the eyes evolve? In living beings, the eyes evolved as sensitivity to light. आई का मतलब ही यही है. It is a sensor to light. वो सिर्फ lights को sense करता है. So first it senses light and second it focuses light. And then creates an image and passes on to you. ठीक है? Do we get it? So light is what? So all the light that you see, you don't see infrared radiation, you don't see UV radiation, क्योंकि उसके लिए हमारा eyes का sensitivity नहीं है. It can't sense. It can get damaged, but it can't sense. ठीक है? All right. So light radiation, and it also has other radiation. Sun sends you all the radiation, but all the other are either blocked or are not sensed by us. Right? So sun will sense you UV radiation, gamma radiation, X-ray radiation, वो सब भी आता है, but that is blocked by ionosphere and all. So the exosphere, ionosphere, they block all the other radiations. ठीक है? And only these three come to the troposphere and stratosphere. Right? So now the heat comes from IR radiation, infrared radiation. ठीक है? And all the incoming solar radiation, incoming solar radiation we call it as insolation. We call it as insolation. So the incoming solar radiation is also known as insolation. ठीक है? Now how much of the total radiation of the sun we receive? It is like no. It is like if this light, suppose this light is giving 100 units of light, how much of that you are receiving on your body? Do you understand this? So same ways, the sun is releasing lot of light or energy, but how much of that do we receive on the earth? That is what we have to write, right? So we receive nearly 2 billionth part. We receive nearly 2 billionth part of the total radiation of the sun. 2 billionth part of the total radiation of sun. So the insolation is 2 billionth part of the total radiation of the sun. Only this much we receive, 2 billionth part. So if you divide total sun's radiation into 2 billion parts, you get only 2 parts. Or a billion part, then you get only, sorry, when you divide it into billion parts, you get 2 parts. This is what it means by 2 billionth. Okay, very good. And this is equal to 1.94 calorie per square centimeter per minute. इतना एनर्जी हमें मिलता है फ्रॉम द सन. 1.94 calories per square centimeter per minute at top of atmosphere, at the top of atmosphere, which means at the top of exosphere. We do receive, that's what I said, that the Earth's upper atmosphere, the outermost, will receive all the radiation. As it will go on passing, the ionosphere will block, for example, the gamma radiation and X-rays and all. Then UV radiation, infrared and light will pass on to the stratosphere. Stratosphere will block the UV radiation. Then what will pass on? Infrared and the light. So we in the troposphere get only the light and the infrared. तो हमको सिर्फ हीट और विजिबल लाइट मिलता है, बाकी हमें मिलता नहीं है. ठीक है? Yes, insolation means incoming solar radiation. Radiation means all the radiation of the sun. Na? It's not only light radiation. It is not the UV radiation. Insolation means all the radiations of the sun. ठीक है? तो all the radiation जब हम बोल रहे हैं तो हमने उसको सीधा कैलोरीज एनर्जी में कन्वर्ट कर दिया. How much is the energy of that radiation? ठीक है? So when you convert all the energy of all the radiation of the sun, it is equal to this much. ठीक है? डाउट क्या है? This is the total energy of the complete radiation received by the. ये क्या देखो ऐसा समझो. ओके ओके ओके. जो एनर्जी है या तो आप उसको डिवाइड कर दो विजिबल लाइट, इंफ्रारेड लाइट, यूवी लाइट ऐसा करके, या यू फाइंड आउट बिकॉज एनी रेडिएशन विल हैव अ नेट एनर्जी. तो हमने उसका सीधा नेट एनर्जी बोल दिया कि उस सोलर रेडिएशन का टोटल एनर्जी कितना है. दिस विल इंक्लूड लाइट एनर्जी, यूवी रेडिएशन, इंफ्रारेड एंड ऑल द अदर रेडिएशन. उस रेडिएशन का जितना भी पार्ट है वो सबका एनर्जी मिला के इतना है. ठीक है? दिस मच वी गेट, दिस मच कैलोरी पर स्क्वायर सेंटीमीटर ऑफ टॉप ऑफ द अर्थ पर मिनट. इन 1 minute, this much centimeter area gets this much energy. Now it's okay? हाँ, बोलो.
There was a statement that a part of UV radiation touches the Earth's surface.
You will do that in your ecology environment. You are talking of UVA radiation. UV radiation का भी B, C बहुत सारा पार्ट्स है. ठीक है? तो वो आप वहाँ करो. हाँ, उसका भी बहुत सारा पार्ट है. राइट? UV वैक्यूम वो सब, तो वो आपको इकोलॉजी एनवायरनमेंट में कराएंगे. दैट्स व्हाई आई डोंट टच दोस थिंग्स. ठीक है? तो यू जैसा इन्होंने अभी पूछा था थोड़ी देर पहले आयनोस्फीयर, उसका बहुत सारा पार्ट है, उसी तरह यूवी रेडिएशन का भी पार्ट है, बट वो नॉर्मली इकोलॉजी एनवायरनमेंट में हो जाता है. सो आई डोंट वांट टू बी रिपीटेटिव. ठीक है? तो वहां करो. हाँ जी. Exosphere top. Yes, that's what we have written at the top of atmosphere. ठीक है? Top of atmosphere till now is top of exosphere. ठीक है? Is this okay? और कोई डाउट है? These are numerical doubts. Most of you have. That's perfectly fine. Right? The ones who don't have too much interest in numbers and science, वो थोड़ा बोरिंग फाइंड करेंगे इस डिस्कशन को कि ये क्या हो रहा है यार, जबरदस्ती एक एक नंबर, एक एक कैलोरी के पीछे क्यों पड़े हुए हैं. ठीक है? But that's okay. Perfectly fine. और कुछ? You have a doubt? यू आपका पीछे क्लियर है? आपने भी शायद, मुझे ऐसा लगा थोड़ा हाथ खड़ा किया आज. ठीक है? सो नाउ नेक्स्ट पार्ट. We call this 1.94 calories per square centimeter per minute as 2 Langley of energy. Because how do we measure insolation? We measure insolation in Langleys. The unit of measurement of insolation is Langley. जैसा unit of distance is meter, तो insolation का unit क्या है? Langley. ठीक है? So how much insolation do we receive? 2 Langleys. ठीक है? ये याद रखना है, ये प्रीलिम्स के मस्त काम आएगा, उसके सिवाय नहीं. राइट? सो दिस इज द यूनिट ऑफ इंसोलेशन. गुड इनफ. नाउ once we understand how much insolation we receive and all, the next thing that we need to discuss is do on the surface of the earth, the region where we live, do we receive this much energy? No. Why? Why don't we on the surface of the earth receive this much energy? One, it is passing through the atmosphere. Second, we are living on a curved surface. है ना? And some of us are in the tropical region, some are in the equatorial region, some are in the polar region. So the inclination at which this radiation reaches us is also different. Now, what does the inclination mean? Inclination means something like this. ऐसा. ये देखो. You can see the sunlight is falling on the earth at different angles. This region it is more perpendicular. That region it is more inclined. दिख रहा है? So what is the effect of perpendicular and inclined? It is like this. If the sunlight is more perpendicular, it is more brighter, intense. If it is more inclined, less. Okay, so because of this, at different places on the earth, we do not receive same amount of sunlight on the surface of the earth. This time it is surface. We are not talking of top of the atmosphere. We are talking on the surface of the earth. So now the next subheading, factors affecting insolation. Factors affecting insolation. Factors affecting insolation on the surface of the earth. Factors affecting insolation on the surface of the earth. Okay. So which are the factors which affect the insolation on the surface of the earth? Let us write one by one. The first factor is the shape of the earth. Factors affecting insolation. So the first factor is shape. How does the shape affect? That is what we saw just now. ठीक है ऐसा. The shape affects the insolation something like this. Alright. Had the earth been a flat surface, ऐसा flat होता, तो everywhere the insolation would have been same. But just because the earth's surface is round surface and spherical surface, every region gets different amount of sunlight depending on what is the angle at which the sunlight is falling at that place. Okay, for example, at the equator, suppose the earth was straight. Right now in this diagram it is tilted. Assume it was not tilted. Then where will the sunlight fall perpendicular? At the equator. Whereas at the pole it will fall nearly parallel. We can say nearly parallel. Okay. So where it is falling nearly parallel, suppose you are holding the torch nearly parallel to the ground. What will you see? The light will go to a long distance, but you will not see many things because the brightness will be very less. And if you hold the torch perpendicular, it will cover very small area, but intensity will be very high. Okay? So it is the same logic. Okay? So in the equatorial region, more sunlight. In the polar region, less sunlight due to the shape of the earth. Okay? So should we write this? लिख लें. So you can write, because the earth is spherical, hence if we do not consider the tilt of the earth with respect to the sun, if we do not consider the tilt of the earth, if we do not consider the tilt of the earth with respect to sun, which means it is at 90 degree. Earth is at 90 degree with respect to sun, not tilted with the sun. Then, if we do not consider the tilt of the earth with respect to the sun, then the equator will get, or equatorial region will get perpendicular sunlight, high intensity. Perpendicular sunlight, high intensity. Whereas poles will get nearly parallel sunlight. Poles will get nearly parallel sunlight with the least intensity. With the least intensity. And the in between latitudes will also receive different amount of sunlight. ठीक है? In between latitudes will also receive different amount of sunlight. So every region will have a different amount of sunlight due to this, due to the shape of the earth. Okay. Then the second, the tilt of the earth. Tilt of the earth with respect to what? The orbit or the sun? Sun. The tilt of the earth with respect to the sun. The tilt of the earth with respect to the sun will also affect the insolation. Okay? How? When the earth is not tilted with respect to the sun, which dates? ये सब किया है ना हमने क्लास में? Which dates the earth is not tilted with respect to the sun? On the equinox date, where will the sunlight be perpendicular? Equator. ठीक है? And on the poles it will be parallel. Why? Because the earth is not tilted with respect to the sun. Whereas, which date it is most tilted? Solstice. And there, depending on which hemisphere is tilted towards, ठीक है? So based on that, intensity will vary. ठीक है? So this is the tilt, right? So you can write the respective tilt of the respective varying tilt, respective varying tilt, VARY, varying tilt of the earth with respect to sun, earth with respect to sun will also vary the amount of sunlight received at a location, amount of sunlight received at a location, and also the duration of sunlight, received at that location. So amount and duration दोनों affect होता है. Okay, right? And we have discussed this, how the amount and duration is affected. You can see here, northern hemisphere tilted towards, so it will receive more amount, and because the length of the day in the northern hemisphere is longer, so it will receive more duration also. ठीक है ना? So this is something that we have already discussed earlier when we were talking of the rotation and revolution of the earth. किया है ना? All right, very good. So this is the effect of shape and the tilt. Now revolution of the earth. Let us talk of revolution. Revolution on the tilted axis. You write this way. Revolution on the tilted axis. ठीक है? So what is the effect of revolution on the tilted axis? Hemisphere change their position with respect to sun in different seasons. है ना? तो ये लिख लें, right? While revolving over a year, the hemispheres change their respective position, change their respective inclination. You write this way, change their respective inclination with respect to the sun. Change their respective inclination with respect to the sun, and hence receive different amount of sunlight. Hence receive different amount of sunlight during different parts of the year. During different parts of the year. Right? Full stop. The result of this is, what do I get throughout the year? Because of this different inclination, different seasons. ठीक है? The result of this is different seasons in different hemispheres around the year. Different seasons in different hemispheres around the year. Okay, so seasons are mainly an outcome of this. All right. Then next is rotation on a tilted axis. Rotation on a tilted axis. So हमने rotation का effect तो देखा था, but rotation on a tilted axis का effect क्या है? What is the effect of rotation on a tilted axis? One, you will get day and night. Second, different latitudes will get different duration of day and night in different parts of the year. Same location in summer will get longer day, same location in winter will get. So this is what the effect of rotation on a tilted axis is. If the rotation was there but not tilted axis, then same day, same night round the year. Okay? So we write this. Rotation on a tilted axis. Rotation on a tilted axis varies the duration of sunlight. Varies the duration of sunlight. At different latitudes, varies the duration of sunlight at different latitudes at different times of the year. At different times of the year in both the hemisphere. In both the hemisphere. Okay. Then next one is slope and aspect effect. Slope and aspect. You write slope and aspect. ASPECT. What is the meaning of slope and aspect? Let us see. इधर देखिए. Now just assume that right now, let us say the earth's surface in this region is flat. यहाँ पे earth's surface is flat. So sunlight is falling perpendicular. But rather than flat, if this region was mountainous, ऐसा, will the sunlight fall perpendicular on the mountain? On this mountain surface, if you are standing here, will the sunlight fall perpendicular? Yes or no? हाँ, ज्योमेट्री लगाना है यहाँ पे, पक्का? आप कैसे खड़े होगे? अच्छा पहले ये बताओ, इस माउंटेन के ऊपर आप खड़े कैसे होगे? क्योंकि जब खड़ा होना पता होगा तो आपको फिर पता चल जाएगा कि परपेंडिकुलर होगा या नहीं. आप ऐसा खड़े होंगे या ऐसा खड़े होंगे? 1 या 2? पहला तो लाइफ में ये क्लियर होना चाहिए कि खड़ा कैसा होना है माउंटेन पे. अगर खड़ा ठीक हो गए तो सनलाइट भी पता लग जाएगा. तो माउंटेन के ऊपर आप में से कौन कौन 1 का जैसा खड़ा होता है और कौन कौन 2 के जैसा खड़ा होता है? हाँ, 1 या 2? 1. अच्छा उसके पहले चलो पहले जमीन पे खड़ा करते हैं. मतलब है ना, देखो आप लोग कितने मजेदार टाइप के लोग हो. ठीक है. अच्छा एक बात बताओ, जमीन के ऊपर आप कैसा खड़े होते हैं? ए या बी? अभी क्लियर हो गया. जमीन के ऊपर तो ए के जैसे खड़ा होता है ना, बी के जैसा कौन कौन खड़ा होता है? एक क्लास में एक बच्चे ने मुझसे पूछा, सर अर्थ के ऊपर अगर ऐसे खड़े होते हैं यहां पे तो ये गिरते क्यों नहीं है? मुझे समझ में नहीं आया व्हाट टू से. मतलब दैट डे आई वाज रियली, मतलब मैं सोचा था तुम आईएएस का तैयारी कर ही क्यों रहा है यार. तुझे तो ये भी नहीं पता है कि अर्थ से गिर क्यों नहीं रहे. ठीक है, मतलब सदर्न हेमिस्फीयर में तो उसके हिसाब से जो भी गया उस बेचारा को तो गिर जाना चाहिए स्पेस में. ग्रेविटी तो है नहीं सदर्न हेमिस्फीयर में. अभी क्लियर है? तो कैसे खड़े होंगे, 1 या 2? अभी बताओ. हाँ, अभी भी 1 के जैसा कौन कौन खड़ा है? माउंटेन पे जाकर के ऐसा टेढ़ा होकर के ऐसा जाना. हाँ पक्का क्लियर है? हाँ, तो सबका सब 2 के जैसा है. तो अगर आप सबके सब 2 के जैसे हैं, राइट, ओके, सो द सनलाइट एट योर फीट, इज इट फॉलिंग परपेंडिकुलर ऑन द ग्राउंड या कैसा होगा? माउंटेन स्लोप के ऊपर. अब ऐसा देखो, बहुत सिंपल तरीका है. सपोज माई हैंड इज द ग्राउंड एंड दिस इज द सन. राइट नाउ द लाइट इज फॉलिंग ऑन माई हैंड. अभी इज इट फॉलिंग परपेंडिकुलर? हाँ, द इंटेंसिटी कैन टेल यू. देखो, है ना, If I keep my hand perpendicular, the light is more intense. If I keep my hand slopey, the light is less intense. Why? Because the light is falling on a, so this is what you call a slope effect. Okay? So what does slope do? Slope increases the inclination, right, and hence reduces the intensity. Is that clear? So slope समझ में आ गया? Very good. Now what is the effect of, what is the second one? Aspect. Aspect क्या होता है? Aspect is, suppose the mountain is this side, यहाँ पे ऐसा है, and there are two slopes of the mountain, 1 and 2. Which one will receive sunlight? And 2 will, despite of the fact that the angle is same, angle with respect to the ground is same ना, diagram में देखो, both the slope has same angle with respect to ground, but one will receive sunlight, 2 will. This is aspect. One is the sunny side of the mountain, the other is the shadow side of the mountain, so that will not receive the sunlight. ठीक है? So this is slope and aspect effect. So लिख लें? Yes. So let us write this down. That slope means the angle. Slope means the angle of the surface. Angle of the surface with the flat surface of sea level. With the flat surface of the sea level. Hence, more the mountainous or hill slope, more the mountain or hill slope, lesser will be the intensity of, more the mountainous or hill slope, lesser will be the intensity of sunlight. ठीक है? Because sunlight will fall at an angle on the slope. Because sunlight will fall at an angle on the slope. ठीक है? So this is called a slope effect. ये mountains और hills में ही होगा. This will happen only in mountains and hills. Is that okay? Now second one, aspect effect. This happens only in mountains and hills. Now second, aspect effect. Aspect. What is the aspect effect? In the mountains also, we might have a sunny side and the shadow side. This is aspect effect. यही लिखना है. Okay, in the mountains also, we might have a sunny side and the shadow side. ठीक है? Which one will receive more sunlight? The sunny side. This is aspect effect. ठीक है? Is that okay? So ये वाला example है. One will receive more sunlight, 2 will receive no or less sunlight. Simple. So aspect, slope, done. Then the last one is transparency of the atmosphere. Transparency of the atmosphere. So what will affect the transparency of the atmosphere if I ask you? What all can make the atmosphere less transparent naturally? What things in the atmosphere? Clouds. So one is cloud. Second, dust particles. So these two things. Simple. Right? So clouds and dust particles affect the transparency of the atmosphere. Clouds and dust particles affect the transparency of the atmosphere and hence affect clouds and dust particles affect transparency of the atmosphere and hence affect the insolation. Clouds and dust particles affect transparency and hence affect the. So for example, if I go to a desert which is very dusty, where there the insolation will be high or less? If it is dusty and there is lot of dust in the air, you do get a phase in the desert where winds are blowing and it is so dusty that the sunlight becomes less. If it is not dusty, if the wind is not blowing, then everything will be settled and you will see bright sunlight. And same ways, if it is cloudy, less sunlight. If it is clear sky, more sunlight. Simple logic है. ठीक है? So do we get it? So these are all the factors which affect insolation, right? So now we in the next class, which I believe is day after tomorrow. है ना? So in that class we'll continue from here, right? And please read the chapters accordingly and come. That's it. Thank you. The ones who have doubts can come over. The ones who are done can leave. Online, sir, is there anything you want me to take up? Online? Nothing. So online people, thank you. Everyone, thank you. Doubts, please come. I'll be here.